We'll go quickly over some of the projects we have done previously. This building was the first unitized curtain wall project done in Africa. This is the Grand Egyptian Museum. This is due for opening actually end of November this year. Also hotel buildings, banks, commercial offices. We cover also residential markets, whether individual villas or apartment blocks. Office buildings. Also in medical industries, hospitals and medical centers as well. In addition to the high-rise buildings with the unitized facade systems and the customization with the different materials, whether it's stone or composite claddings alongside the glass. Transportation hubs. This is Adli Mansour Transportation Hub, one of the largest hubs in Africa. Convention centers. Again, different office buildings, different designs. Shopping malls. So basically, that covers a lot of types of projects and different segments. Which our product covers in general, and we provide the service for that. Again, thank you very much, and we're looking forward to the excited conversation, the rest of the convention, and come out with very good discussions. So. Thank you.
Thank you, Mr. Gamal. Now I have the pleasure of welcoming an individual I have personally engaged with, a visionary in design, innovation, and I remember he once told me, the devil is in the detail. Please welcome Mr. Gurmukh, Architect Gurmukh Singh Panesar, founder of Grasp Design. Thanks. Please give him a round of applause.
Thank you for the introduction, Jay. So as he's introduced, I'm the principal architect of Grasp Design Limited. I'm also the vice chair at the Kenya Green Building Society. So today we'll be talking about future of facades in tropical and subtropical highland climates. Specifically, 3 items. We'll be talking about self-shading forms and systems. We'll be talking about dynamic facades, and we'll be talking about electrochromic and thermochromic glass, and all these in the context of, tropical regions such as Nairobi, within, Nairobi, Singapore, and certain areas in Africa. So some of the context around this is tropical climates normally have intense solar gain. We have cool nights and high humidity. Now this obviously isn't applicable for all areas. For example, at the coastal regions, you do have lower diurnal ranges basically during the day, Humidity is high as well. So, and there are other aspects to consider, such as proximity to the sea, corrosion, and things like that. However, some of the key elements is you do need to cut out solar heat gain. So facades must balance solar control, natural ventilation, and daylighting. In addition to that, with urban centers growing, we're having other challenges as well, things like air quality and climate change. For example, if you're designing something in the middle of Lagos or in Nairobi, you will have challenges with air quality. So how do you balance a passive system whilst letting in, ventilation naturally, but at the same time you have to cut out the pollutants, you have to cut out the particulate matter, and at the same time cut out noise as well. So the multiple growing factors that are now, increasingly making the facade design complex. In addition to that, climate change is another concern. We don't know what the impacts of that will be. Increased temperatures will mean some of these passive approaches may not work. We may need to introduce more active approaches, again, which contribute more towards climate change, so it's a vicious cycle. And lastly is optimization is essential. We need to use all the tools at our disposal, parametric design, BIM, and digital manufacturing to make sure that we're doing efficient facade design. So coming down to self-shading forms and optimized shading geometry, now let's go to the basics first of all. If you're looking at climate such as Nairobi, you need to have your orientation east-west and your longer facades facing your north and your south. It's common sense. We're close to the equator, it works. In addition to that, you can introduce things like courtyards that can provide some kind of self-shading, and this is some of the more basic principles that must be implemented. Unfortunately, a lot of people don't, and they still have a lot of long facades facing the west and the east. And some of this is due to bad design, but some of it is also due to poor urban planning or urban planning that has not really caught up or did not factor this in. So you have, for example, I'll give you a very good example. On Westlands Road in Nairobi, just along right behind here, we have very linear plots, but the orientation is against what we're proposing. It's basically you have the orientation along the north-south axis. And because of that, you have your longer facades facing east and west. Now, because of some of these urban planning divisions in early years, I think this is now starting to affect high rises basically in the region. Now, as you go more advanced in self-shading forms, you can have self-shading forms in terms of complex curvature, which can be parametrically derived. And you can also have this in your fins as well. So optimization of sun shading devices, optimization of your brise soleil, and your fins as well. So with this kind of passive approach, you have less challenges compared to active systems, which we'll be covering later. So we'll be covering obviously dynamic facades, electrochromic, and so on. I'll give you some examples right now. This is a project that we're doing in Westlands. It's on about 7.5 acres. So over here, the aim was to have it as passive as possible. So we kept orientation very basic along east-west axis, longer facades again on north and south, self-shading with the fins using, concrete UHPC, that's ultra-high performance concrete as well for the fins, so you can get them as low as possible, optimization of the shading. So starting off from the less complex, your courtyards, your orientation, let's go now to something a bit more complex. This is an example in Singapore. So here they basically used 7,000 triangular aluminum sunshades, and these were parametrically designed to basically optimize sun shading while letting in light. So again, this is a very good example. Singapore's climate is quite similar. It's a good example of how you can use parametric design in the early stages, kind of optimize material use and ensure you're getting the best of both worlds, cutting out solar heat gain, but also making sure you're getting good light ingress. The next project is now taking it a step further. So here now you have a self-shading form. This is not built. This is a proposal by Morphosis Architects from New York. And basically their form was generated through parametric design as well. And if you look at it carefully, you can see all of these fins actually do have dates on them, and they've been generated and optimized based on certain sun path diagrams, basically, that they're fed into their parametric models. Now, this is now obviously the extreme end of self-shading optimization. However, anything in between would be useful. Even starting with the basics, if you can get that right, that will be a bonus basically in getting your building as sustainable as possible right from the get-go. The next item we'll be discussing is dynamic facades. So these are now adaptive skins that respond to sun, wind, temperature, can be controlled via building management systems and sensors. Some of the challenges with this are obviously moving parts and cost. It's more difficult to design, install, and maintain. Certain considerations like IP ratings for moving parts. For example, I'm sure for the designers for the Al Bar Towers in Abu Dhabi, they would have had to factor in IP ratings for their, all their linear actuators basically that they're using over there. So these are key things. Those seals do wear out of time after a while. So you need to see what the implications are for these moving or dynamic facades. So this is one of the examples of a dynamic facade. So in this one, the mashabiyah basically opens and closes with the sun path based on sun exposure. And there is a significant reduction in solar heat gain. Now, obviously with this, the big challenge, as I've mentioned before, is the moving parts. And anything with moving parts, it becomes a bit of a maintenance nightmare over time. So there's that. There's also the fact that with these kinetic facades, the other issue is also views. Because they're highly opaque, what happens is when they're closed, the views and daylight also reduces significantly. So it's a balancing act between the two. And obviously the cost for commissioning these kind of systems is very high. Another example of dynamic systems is the Institut du Monde Arabe in Paris. And this features an iris kind of approach, similar to what you have in digital cameras. So if you see all the apertures over there, the round apertures, they actually have like an iris system that closes to let in light and heat. Well, let in light and regulate heat rather. So again, this is a good example. There are two different systems. If you go back to the one in Al Bar Towers, that's how it operates. So you can see the triangular kind of, open and closed kind of settings in this facade. The next item I'm covering is electrochromic and thermochromic glass. Now, between the two, I think electrochromic is more widely used. Thermochromic is quite niche. It's not used a lot for good reason, and I'll come back to that in a bit. However, in basics, basically the thermochromic glass tints based on ambient temperature. Electrochromic glass tints based on electrical charge. So it's a lot easier for you to control electrochromic glass than to control thermochromic glass. Also, thermochromic glass doesn't work very well for temperate climates. And the reason being, this is more suited for, temperate and not for tropical climates rather. The reason for this is because your ambient temperature tints the glass. If you had it in Nairobi, for instance, the glass would always be tinted because it's hitting 25, 26 degrees ambient temperature, your glass would always be in a tint state. And that would then defeat the purpose. However, in temperate regions, you have winter time where the ambient temperature is low, but you still don't let the sun in. And during the summer, you don't want to let the sun in. So what happens is, during the winter, the glass tint is not on because the ambient temperature is low, but it still lets the sun in. And during the summer period, the glass tints because the ambient temperature is higher and thus cutting out solar heat gain. So it works well for temperate regions. I wouldn't say it's very applicable for tropical regions. So the first project to use electrochromic glass was one that we did as well, Microsoft ATC. In this one, we incorporated electrochromic glass from Sage Glass. And we also incorporated interlayer from Kurore, Sentry Glass, in that glass facade as well. So this was a gradient filter basically on the glass. And our aim was basically to cut out the daylight factor. So we wanted the views from eye level to be maintained, yet we're cutting out all the glare from the sky element basically. And this was attached to, so on this building, which is Dunhill Towers in Westlands, all 4 facades were kind of equally exposed. So one of the main challenges was the western facade. And the reason we had to change this from the original facade was the developer did not want to kind of affect the facade look of the building. So we had to replace the existing glass with electrochromic glass, so we'd actually tint it. And this kind of brings the solar heat gain coefficient down to almost 0 and a full tint. Now, this is controlled with a sensor on the rooftop, and that picks up, the radiation levels. So if it picks up the solar radiation from the west is hitting a certain amount, it'll tint that facade. Now, in turn, what happens is the internal lighting condition reduces. It becomes darker, basically. And that triggers the lighting sensors, which are built into the light fittings, to adjust automatically. So you're getting, 600 lux on your desk. So this is kind of the integrative approach that you need for smart buildings. So where the glass automatically tints, reduces your solar heat gain coefficient, but at the same time, your lighting levels are maintained because of an increase in lighting levels to your light fittings. So, and this is all powered, via PV and things like that. So there's a lot of sophisticated systems in this project. Another thing to factor in for these glass, I know it's not very specific to this topic, however, it is useful, is U values and acoustic ratings as well. So for this one, we used a double glaze system, which is about 38 decibels RW, and we had a U value of 1, which is quite high, considering if you look at it from an international point of view. However, because our general ranges are not too high, you don't need to get too low on your U values within tropical climates. Unless you have very high variances in your day and night temperatures or your exterior and interior temperatures, then you must look at reducing your U values for your assemblies. However, in this case, a U value of 1 was sufficient. Most of the times, the U values of the windows are normally lower than that of the wall assemblies. So it's something to be cautious about. The next project is an example of thermochromic glass. So this one's used in the University of Cambridge Civil Engineering Building in the UK. And as I mentioned, so this tints basically when a certain temperature is exceeded. Not very effective or not very applicable in a tropical climate. Useful for temperate climates where you have, winter and summer, but not so useful in tropical climates. So I want to also cover how we can integrate local context into this. So with the optimization of your facade items or your facade fins and brise soleil, you can integrate, modern technology, but with local craft. So using locally derived materials, clay, timber, perforated metal, as much as possible, and obviously considering practical elements such as durability and, UV exposure in this region being very high, you need to factor that in. The other item I want to discuss is future outlook. So what's next in terms of facade systems? You have things like algae-based facades, where your facades can generate energy. PV facades are already a thing, where you can, have generation of power from your facades, where you have transparent or translucent photovoltaic panels on your facade, and AI-driven predictive facades with phase-changing materials. Now that's obviously next level. But yeah, I think this covers, what the future might look like. And I hope this has been useful. Again, for tropical regions such as ours, you have to be very careful about what to do in these facade implementation strategies. However, some of the key things to take away from this is start with the basics, get the orientation right, get your basic shading right, and then you can optimize further using design tools, parametric design, BIM, and you can use CNC fabrication as well to optimize material use. Thank you.
Good insight. Now, I would like you to join me in welcoming QS Joseph Kungu from Tower Coast. Please give him a round of applause. Let's.
Right. Thanks for that. Now, so my name is Joseph Kungu, as the introduction has been done. From Tower Coast Consultants, I'm the managing director. And I know Gurmukh has taken us through very interesting facade, modern way of facade design. But you also realize that that also comes in with cost limitations. And I think what I want to address, I don't want to break your bubble, but I think it's important we also look at it in terms of how does all this relate with the way construction is in terms of cost. As you can see, that's myself, founder of and director of Tower Costs, as well as the various membership that I belong to. You look at the introduction, one of the things that you find is that facades play a very critical part in terms of, as an architectural feature, in terms of the aesthetic elements, as well as in terms of the functionality of a building. And with this, you find that in terms of energy efficiency becomes quite important, weather protection is critical, acoustics become also very important. But also we find that there's a lot of increased competition in design and the demand for innovative, high performance and visually striking facades. And this will continue growing as we keep going on. And as consultants, both whether it's architects, engineers, it's important that we see how we can be able to balance that ambition by making sure that we get realistic budgets. Now, I've sampled a few projects that we have been involved in, and whereby you find that the market keeps shifting in terms of the facade. You can see like Parkin, which is by Radisson, which is right on the left. Delta Chambers is the one which is at the middle, and we have got Park Medical Center, which is on the right-hand side. You find that all these have got striking kind of facades, and you get to see that in each of them, the designers have tried to come up with something which is outstanding to make sure they address things to do with the functionality in terms of the acoustic issues and the functionality. And that's what I'm going to be able to focus a little bit on in terms of how do you strike a balance in terms of that cost, and how do you make sure then you get a budget that the client is able to meet, not forgetting that all these aspects have to be balanced. Now, with the evolving facade market, you find that there is the historical element which has come into place, and whereby historically it was more of just enclosing the space. But with modern trade, you find that a lot has changed in terms of being able to make sure that the facades are able to define the building and the identity of the building itself, as well as the technological innovation, whereby now, in terms when it comes to design, as Gurmukh has mentioned, there is things to do with high-performance glass, smart facades, photovoltaic cells, thermochromic glass, and all these, which is part of where the direction is going in terms of evolving facade market. Now, with that, as I mentioned earlier, things to do with aesthetic considerations come into place, environmental considerations become critical, and also even the cultural influence also becomes quite important in that regard. Now, when it comes to cost realities, you find that the projects face intense pressures due to the increasing material cost. And with this, then you find that we must be able to strike that balance, as I mentioned earlier, so that you make sure that the developer, and even for us as consultants, we ensure that the client is able to get the value for that they're investing into. And that's why the material cost, considering that whether it's aluminum you're looking at, whether it's glass you're looking at, accessories, all these are important materials. So you find that the capex involved in terms of imports and the duties and all that becomes quite prohibitive. One of the things you realize that recently there was also even a duty which was introduced, which also is making this kind of construction quite prohibitive. And these are realities of the day that we need to see. How do we manage to be able to give the clients still a good product at the same time being able to manage the costs associated with that? Definitely, I think is a challenging environment, but I believe that it's only those kind of designers who are open to be able to explore other avenues going to be able to face these realities in a massive way. Now, having said that, then how do you balance the design ambition with the budget constraints? I believe that the early stage decision-making becomes important. And the thing I've noted is that those days are gone whereby the designers will just sit in a design room and come up with all these designs without consulting the various manufacturers and the fabricators, so that we get these ideas early enough and we collaborate with them so that we get better understanding of how to be able to go about it. And in that case, then you find that even for us as QSs, those days are gone whereby you say that the cost per square meter of the facade is this much, because you find that there's so many elements which keep changing every day. So what that means is that we have to keep allowing ourselves to be able to collaborate and to be able to even seek a lot of clarifications with the various suppliers, manufacturers, to do with even the fabricators, so that we get the best position as far as those materials are concerned, so it becomes easier to be able to give the clients the value for their money. Definitely with that also comes in the value engineering, because you find that I've never come across a client who told me that I'm okay with the budget. They always raise questions. They always want to push the envelope. And as a result, you find that you have to keep looking for which are these areas we can be able to do value engineering so that we get a product which the client and everybody else is happy about. And definitely also things to do with alternative design solutions become part and parcel of the kind of job that we're doing every day. Now, the other important thing, even as we look at budgets and the facades, is to look at the impact of these facades to do with the sustainability. How does that affect the sustainability? And that's why still in the same way, the element of design solutions and all these alternative solutions come into place, so that we make sure that the sustainability element is clearly addressed. Now, having said that, the thing I've noted is that there is also a lot of green building technology which is coming into place. And I know that we have got a few buildings, even right here in Nairobi, whereby this kind of design has been carried out. And it's becoming very attractive in terms of being able to meet sustainable requirements, but also at the same time, just be able to improve even the whole ecosystem and the environmental element of the whole city. So these are to do with technological innovations, whereby with advances in AI, robotics, and automation, it will lower the cost of custom facade systems and allow for more innovative designs at lower cost. Then in terms of circular economy, whereby we need to look at recycled and upcycled materials, which may become more common in facade systems as far as sustainability goals are concerned. The other element is about collaborative approaches, whereby we increase collaboration to help manage both the cost and design effectively. So, what are the takeaway points in all this? That facades are both a design challenge and cost challenge in modern architecture. Technological innovation and sustainability are key drivers of both cost and design evolutions. And as consultants, we must be able to adapt at balancing the client's budget with the architect's design vision, while at the same time considering the long-term performance and operational cost. And that is the end of my presentation. Maybe I'll open it up in case there's any question someone might have in terms of how we can balance the cost and the design. Any question?
I think we'll do the question Q&A at the networking lunch.
Okay, thank you.
Thanks.
Okay.
Thank you, QS, for your valuable insights in cost efficiencies and sustainable budgeting, which we know is a good challenge. Okay, I'd like to now welcome Mr. Devendra Lada from Prime Aluminum. Please give him a round of applause. Mr. Devendra Lada.
Thank you, everyone. It's a pleasure to be here today. We have been trying to partner with ZAC World of Facades for the last many years. This is our third event in Nairobi. The last event was in 2019, and we have been trying to convince them to come to Nairobi for quite some time. So today is a pleasure to be here, and it's also, we want to put Nairobi on the global map of their circuit. As you can see, they have a very wide they span the global network of the facade systems. So what we have been partnering with Zach World of Facades for the Nairobi event, and today I will be speaking about the core pillars of supply chain optimization. And what are the core pillars of supply chain optimization? The material selection, sourcing and delivery. We'll give you a case study of that. And we've got a project execution case study as well. We'll also be speaking about high performance building facades that balance energy and efficiency. And as we had QS Kungu also talk about price versus performance and striking the right balance, we'll give you my perspective on that. And key stakeholders and the roles in the facade projects. So starting with what type of material selection the way I look at it, because we are a facade contractor, and generally in terms of material selection, we want to understand what are the type of products that we are going to be installing on the project. So we've got things like glass hand railing, windows, doors, we've got cladding, shop fronts, curtain walling, sun shading, you've got terracotta, stone cladding, glass canopy. So as you can see, in a facade project, there's so many different elements, and we as a facade contractor generally have to be able to provide solutions for all of these type of products. So in terms of material selection, what we like to do is first identify the design intent. Then we have to comply to the specifications, and after we do that, we select the appropriate system. And once we've selected the appropriate system, we have to select the appropriate glass, because we have to ensure if there's a specific solar heat gain coefficient or a visible light transmission percentage, we have to be able to comply to it. Then we identify the suitable suppliers, and then we source and deliver the materials to the site. So as you can see, for a facade project, there are so many different products and components involved that everything has to be sourced from all over the world. This is a typical example of the type of suppliers we work with and where they're globally based, and everything has to come together at the same time, and we have to be able to make sure that the right products are coming to the right quality, and they arrive to Kenya and East Africa, so we can do the installation for that. So this is a case study for Britam Tower. We were the facade contractor for Britam Tower, which we handed over in 2018. And it was a complicated project. So we had to first understand the facade concept. So this is the facade concept. So what you have over here is you've got a facade which is a double skin facade. So this is the concrete slab over here. And then there's a catwalk, it's a floor-to-floor glazing. And there's terracotta rain screen on the outside. So this is the floor-to-floor glazing, the openable vents, the maintenance platform, the terracotta rain screen, and the permanent ventilation. Now these are many, many different components coming together at the same time. And we also have to comply to the specifications. So there was the specifications that were set out by the facade specifier, certain type of glazing, certain type of powder coating, certain type of alloy and the temper, and the terracotta rain screen was a Hunter Douglas product. There was also grating, which was a catwalk. And what we have to do is we have to comply to the specification. At the same time, for the facade had a performance requirement. So there was an air infiltration, water penetration, wind resistance, all these type of performance requirements. So we have to make sure that we select a system that complies to all of this. And we have to identify the right suppliers. So from the slide I showed earlier where we've got the different suppliers, we identify the right suppliers for doing this type of work. And then we take the project scope of work. So the project overview was having curtain walling. So we identified the system supplier for the curtain wall part. You've got the doors and windows in the facade, so we've identified the system supplier, the steel work. So in our factory, we made all the steel work, I-beams, and because it's a secondary facade, there's a catwalk, then there's a terracotta, so we worked with the Hunter Douglas product for that. And all of these items then have to come into the overall program. So there's a design and engineering element, there's a procurement element, there's a fabrication element. All of those items come into the overall program, and we have to make sure that the sequence of procuring all of these items has to come at the right time and the right interval so that we can be able to do the facade installation. So this is during the execution of the project. So what we did for Britam Tower was that we, as you can see, our guy over here is placing a cast-in anchor before the concrete is poured in. What happens with that, because you've got a double skin facade, instead of drilling all the I-beams to the slabs once they're casted, this allows us to position them before the concrete is poured. This is more robust and much more durable and more flexible. It just involves a bit more early planning, but this is the better way to do it. This is during installation. So all the I-beams were, you can see over here, you've got I-beams, you've got the floor-to-floor glazing, then you've got the I-beams which are cantilevered fixed from these cast-in anchors, and then on top of that there's a grating that is going to then hold the terracotta. So that's how the facade concept was. So in the end of, once the project was executed, we've got a very beautiful facade. That landmark project has to obviously withstand the wind loads and everything, and we identified the right systems to be able to comply to the requirements. This is a view from between the catwalk and the curtain wall, the terracotta and the curtain wall, and this is what the final outcome was. And this is a project that now stands tall in the Nairobi skyline, and it's a landmark project. So these are some nice pictures of Britam Tower and the Nairobi skyline from Nairobi National Park. Another picture from Nairobi National Park. And then what makes a high performance facade? So what are the key characteristics? So I'm from the facade contracting background, so I'll give my perspective of what I consider to be the key characteristics of a high performance facade. So I would say it should be energy efficient, high energy efficiency, durable to weather resistance, indoor thermal comfort for the occupant, structural durability, has to be sustainable obviously, and in Nairobi we now do have a problem where the facades and the windows need to be acoustically well designed, because noise is becoming a problem in Nairobi, and obviously they have to be aesthetically appealing. Also for energy efficiency, there's various different ways of doing it, but the most simplistic way is to, you've got the outside sunlight which is coming into the building, so you can use single glass, or you can use double glazing, which is 2 layers of glass, or not so common in our market, but there's also, for example, extreme climates, you've got triple glazing as well. But generally in Nairobi, between these two, single and double glazing, most of the projects are based on this type of glazing selection. Then also the right system, a durable system, has to be selected in terms of the performance, in terms of the hardwares, and making sure that the right components are used to ensure long-term durability and functionality. Another thing is selecting high-performance systems. So this is the sliding door. For example, I think this is a Schuko sliding door for a project that we did. You've got the larger the width and height, we selected a system that can be able to have a smooth operation for that. So this is a 4-panel sliding door, and this is a cross-section diagram for that. Another way to, well, this is a technology for a high-performance facade. This is a project that we've done in Nairobi called Trade and Development Bank. This is double skin facade. So going back to what architect Gurmukh was saying, so double skin is the one strategy to be able to make the facade more high performance. This is a project we're doing in Rwanda, in Kigali, where again there's a double skin facade. There's a sun shading elements that is projecting from the curtain walling that looks something like this. So these are the 3D analysis for that project. This is the typical detail for that project. So what we've got is a unitized curtain wall system with the sun shading that is cantilevered from the end of the curtain wall mullion. So it's sticking out like this. And in this particular slide, you will see how it is projecting out over there. And that gives a higher performance to the facade, also aesthetic appeal. Another way to make the facade high performance is using good natural lighting. So you can see in this particular project that we've done, there's very good natural lighting that is coming into the building. And being in Nairobi, being on the equator, obviously our natural light, making use of the natural light is very is good to do that. Now the next topic I was talking about was price versus performance and striking the right balance. So one of the things that we've been struggling with is, and I'm happy that QS Kungu said that the days of doing square meter pricing have gone. So I was going to give you a round of applause at that point, because nowadays we've got softwares that are able to build your facade in the software like this. It calculates the amount of material that is required. From the software, you get all your material lists. You can play around with the different type of systems that you can use. Over here, the connections, the fabrication data, and you've also got the CNC machines that connect to the software as well and be able to give you proper fabrication. And what these softwares let you do is they let you build your own facade onto the system. And from that you can play around with the pricing. So, because like you can see over here, you've got a facade that is X by Y in terms of width and height. You've got the same one, width and height, but in here you've got two openable panels. But in here you've got two openable panels and a double hinge door below over here. Now one of the mistakes that has been happening, I think, in the East African market is that the price, if you go by square meter price, obviously the square meter price will be, if you go on a square meter base, it will be the same price. But because there's a hinge door, the price has to obviously increase. Logically, it has to increase because there's more hardware going in. So making use of these type of softwares and being able to build the facade systems and price the estimation correctly, then this is the correct way of doing it. So this is an example of Shuko system where, for example, you've got a window that is a casement window or a sliding window. Now, if you go to Shuko, they'll say, okay, if you want a casement window, we have 8 or 9 different options. Now, all of these different systems are of a different category, and all of them are of a different pricing. So we have, when it comes to the project specification, if you're working with Shuko, for example, the system has to be selected and then accordingly has to be priced. So this is a good platform for the architects and the cost managers in this audience to be able to connect with Shuko and see the different systems that are available and what would be the difference in quality and performance. So how the softwares work, so we do use these softwares to be able to price correctly. We do an estimation, so we take the purchase price of the aluminium, the purchase cost of the hardware, the purchase cost of the gaskets and the system. It goes into the fabrication costs and goes into the estimation price. That you feed it into these type of user interface. You build the window on the software, so each window can be built as per the previous elevation that I was showing. And that does a material analysis like this. All the prices come out, and then you get pricing based on that. So that's the correct way of pricing. Now the next thing I was going to talk about was key stakeholders and their roles in a project. So obviously every construction project has the owner, the consultants, the construction workers and the contractors. So we are a facade contractor. We fall in this category over here. As a subcontractor, we are the facade contractor. So what I wanted to explain, the key stakeholders that we work with in this position. So first of all, there's a system supplier, so a right system has to be selected. So for example, Shuko is here, they're a system supplier. architects can approach Schuko and they can say, okay, which system do you want, sliding system, folding system? They will provide you with the hardware, the aluminum, the certification, the testing. Also, if there's specific type of handles, they will be able to offer that. And then you've got that, then goes to the next item comes the aluminum extruder. So the aluminum extruder is the one that will have a sort of a setup like this. The raw aluminum comes like this, it gets cut, goes into the extrusion process, goes into the painting process, the anodizing process. So basically aluminum extrusion is what we have, you've got the raw aluminum, goes through a die and out comes the aluminum. So that's the extrusion process. The next one is the glass manufacturer. So you've got people like the Guardian is also here with us today. They have a float plant like this, which is a massive factory. You can see this is a typical float plant, and glass is made from the silica, and out comes the glass and goes into the container. That glass then goes to the glass processing companies. So the cutting, the laminating, the double glazing, that happens at this stage. And then finally comes the facade contractor, which is where prime aluminium come into the picture. So a typical facade contractor will have a factory setup that looks like this, or like this, where you've got different machinery. This is a very modern factory that is probably not in Kenya, but I'm sure it's somewhere else. Then we do the fabrication, take the material to site, do the installation, and that's basically what the facade contractor does. So the facade contractor, from the whole collective stakeholder group, we are the ones who do the dirty work. And that's where we come in. Thank you.
Thank you, Devendra, for sharing your fruitful insights on aluminum systems and your evolving role on all the relevant facades that you've presented today. Please welcome Ms. Ant, Group Director at FBW, to present to us her insight. Thank you. Please give a round of applause.
Hi, thank you. Welcome everybody. I'm covering a very different subject from everyone else, it seems. Solid facades, not glazed facades. So first of all, let's start with what we're going to take you through. Just wanted to give a bit of a highlight how brick making has evolved. Intro to FBW, of course, in case you don't know us. A brief history of brick making techniques. Come back to East Africa. And then we're given a case study of a multi-story building and also taking you through opportunities, in particular in respect to circularity. So FBW has been in East Africa for over 30 years with offices in Nairobi, Kampala, and Kigali. Our multidisciplinary team includes architects and engineers, all deeply familiar with the region's challenges and opportunities. Our strengths lies in combining international compliance with local delivery. We ensure quality through rigorous site monitoring, direct involvement from senior staff. This hands-on approach has carried us the trust across diverse sectors and projects. These are our offices. So, deep dive very briefly into the history of this important material, especially on this continent. First, sort of dried bricks are recorded from around 7,000 BCE in Jericho, which is in present-day Palestine. Then fired bricks have first been seen around 3,500 BCE in Mesopotamia, which was improving strength and durability. Then the Indus Valley civilizations around India, Pakistan, Afghanistan, already around 2000 BCE, started to sort of create bricks in large quantities to support the urbanization. Obviously, sorry, just very briefly going back, down there, the picture you see is the Egyptians also having it in their motifs, how they important both fired and mud bricks were there to their civilization. Of course, building on that were then the Romans, but since this is a facade conference, I thought it was interesting to note on the top here. So you will see the, how am I going to do this? Okay, so as much as the Romans built everything you see there in the big background in bricks, what they actually showcased here in the Forum Romanum, so in their public spaces, was everything made in marble. So the bricks were supporting everything, but were not visible. So in that, they also, as you can see on the bottom picture, they also sort of created a very distinct workflow just because of this huge demand in brick they needed for their full empire. So medieval Gothic brick architecture brings the brick to the forefront. So for the first time, bricks are actually being used as the facade. And obviously, through time, the process was improved and the quality was improved. So just very briefly, 1700s bring industrial kilns, further increased production. 1800s bring mechanized production, and 1900s automated advances. 2000s sustainability innovation. We'll come back to that. So the picture you see at the bottom, which is again in India, there's a lot of brick making still involved at large scale, and I think these factories haven't really changed over centuries. What are techniques that are used in East Africa? I think the top picture shows you why brick has such a bad name. It's seen as a raw material, it's seen as a material where you can't control the quality, and a lot of that has to do with this sort of very basic process, which has been still used up to this day. You make the bricks by hand, you kind of cover them in mud in this kind of configuration, and then you create a fire at the bottom. So what you get is very brittle bricks on the outside, and then well-fired bricks in the middle, but you don't get size, consistency, all that. So in result, of course, you see all the walls are very uneven, and so there are different products on the market. So the one which, okay. This one here, you'll see that's already industrialized production, but then there's also this system we will be talking about a bit more in our last section, a smart brick wall, which here you can see how the different types of brick systems, they actually decrease the amount of embodied carbon. So one system I want to mention in that regard is the SCUT Smart Brick Wall System, which was developed in over 10 years, together with, funded by the Swiss Development Agency in Rwanda and the Greater Lakes region. So this brick has a uniform size, which also has some holes in, and that reduces already its embodied carbon. And then the whole project was evolved how to reduce embodied carbon in residential construction, affordable housing, and this whole system was developed where you have a double skin and you allow the structure and services to run through in those cavities. So this is one of the systems we've also been using in some of our projects. Then let's just jump a little bit. Crater Malawi. We chose this building to show you how a very basic material, as I say, which has a bit of this stigma attached to it, can also be used very efficiently in multi-story construction. This is a 5-story building. And as I say, Malawi is in some cases not very well developed. So we just wanted to take you through why the client in this case actually chose this kind of material. So we've talked about, in the previous discussions, was talked about durability, sustainability, and sort of solar control, and also the, delay in thermal gains. So for all these kind of benefits, brick facades actually work very well. It's a local material which you can produce in country. That minimizes the transport impact, it creates local employment, and generally you create a facade which has much less maintenance, no cleaning, self-cleaning, and say it also has these thermal benefits. So the facade we created, maybe just to give a little bit of a background, the project was originally designed in the UK, and the client is the Wellcome Trust from Liverpool. This is a medical research facility. So as much as in Europe brick facades on multi-story buildings are very much commonplace, they are not as much in East Africa, so we had to translate the requirements of stability, durability, and structural integrity with a local contractor and the local supplied material. So why did we choose, in this case, a double sort of skin facade with a cavity? It's actually better practice to have a double skin on your brick because that allows the brick to dry out faster, and the bloom you can sometimes get on the surface is reduced for that because the facade dries out and is more ventilated. So as much as we then specified, of course, all the products you can get in the UK, all the anchors, all the wall ties, the shelf angle. The contractor chose to sort of go with their own way, and down there you can see the wall ties they've created, then the shelf angle. So it has been interesting, but as to summarize our experience, maybe it's good to say that we have created already in the design the supports at each level. So you see the band of the concrete supports at each level, which really assisted in using this on a multi-story application. And also we talked about shapes and how can direct your glazing away from the sun. So that was the idea with this facade. So the glazing is set away from direct solar gain, but that created, of course, a lot of difficult details, in this second skin. But the advantage was also that, for example, rainwater downpipes are visible, but they are integrated into the brick facade. So that was the result. Difficult geometry, but I think they managed to execute it quite well, and the facade is doing very well. This was opened last year. Okay, so some more projects. We've been using bricks. This is an international school, also in Kigali. So we've been working with the SCAT system we had mentioned before. So using it for making different textures, patterns, and again drawing in a very highly trafficked environment to draw on this idea of self-cleaning and just being a easy maintained facade. Then this project was opened earlier this year. This is the Zaria Court, also in Kigali. What you can see on the far right is an existing building, so this project was an adaptive reuse. And then the brick elements, this curved facade with patterns and the like, that was all added. That's new built to bring this building a bit more to life. We again worked on this with an international team. Then, our last segment is more to do with how we can improve sustainability of this important facade material. So one project I want to mention is Green City Kigali. I don't know if you have heard about it. So it's a large master plan project. Which involves the full hill of Kinyinya in Kigali, 600 hectares. And in the foreground, you can see that is the 16-hectare pilot site. So on the 16-hectare, we're also looking at designing affordable housing typology, schools, sustainable infrastructure, and the like. So, but in terms of the 600-hectare master plan, it was important to just question how we can create cities that are self-sustaining in all their supply chains. And in that thinking, it was important to find a material which fulfills these criteria. You can see here on the left. So the pillars of the project are affordable and socially equitable development, creating structures and infrastructure for climate change adaptation and mitigation, looking at resource efficiency, and creating culturally sensitive urban development. So as mentioned, this is an affordable housing project, and this GATT system, which was already developed in Rwanda, seemed to be the right building material, because also just if this is the shape of the hill, in this valley down here, there is actually huge deposits of clay. So it was making a lot of sense to include in the master plan that we will create employment through a material which can be found on site and which will then develop the hill and actually be in line with the pillars I've just explained. So circularity, I think everybody talks about it. Brick is really a circular material. You start with the manufacturing. You obviously use it in construction. Then as you disassemble it, it will then afterwards either be reused or it returns to soil, and then the whole circle starts again. So there is no real waste product, anything which is not natural. The challenge, though, on scaling this project and looking at a solution for rapid urbanization, which this project is trying to address, is actually the amount of bricks that are needed. So when we looked at the brick product, we have looked at, for the SCAT system, only on the pilot site, which we showed in the foreground, the 16 hectares. We had calculated we would need about 10 million bricks, which in these efficient kilns, which were also created for, in the SCAT product, they would take about 3 years to make, even if with the biggest size of kilns they would offer. So what could be the solution? And this one solution we looked at would be to just, look at compressed earth blocks as well as another material, maybe use it on the inside, or look at alternatives ways to make bricks. So then we came across this interesting product, Oxara. Maybe we should invite them next time to talk as well. So this is an innovation created in Switzerland. We're taking demolition waste and clay, and they're producing, low carbon binders. So like normally in compressed earth blocks, when you don't have so much clay in your soil, you actually need to use a lot of cement in it. So this creates a block which looks more or less like, or a tile, which looks more or less like concrete or clay, depending on the pigmentation. But it's not, it's completely sustainable and it's cement-free. So that means the result is 70% less CO2 per cubic meter of building material. Now, one problem is in East Africa, because we're still at the beginning of the urbanization, we don't actually have as much demolition waste. So one thing you can also use, another cementitious material, is volcanic lava. Doesn't just need to be ash. I read that again. And with, again, the clay we have talked about, you can create these beautiful products which then in the future should be able to also replace bricks, as we're gearing up for this kind of production in East Africa. Okay, then just going back, say brick seems to be having a bad name, but I think there's endless opportunities also to use it in more traditional or modern ways in facades, and I hope we've given you enough insight on this, that the challenges ahead but also the opportunities ahead. Thank you very much.
Thank you, Ant. You could give another round of applause. That was a detailed, sustainable facade perspective. It's something we don't get to see very often. Thanks. I think we can break for a networking lunch. Then we can see you back in an hour's time. She is directing what I have to say. I'm sorry. See you in an hour's time. Please, let's break. Thanks. Afternoon. We hope you all had a good networking session. And I see we are a bit full. Or for those who didn't have lunch and came right now, welcome back. We'll welcome Rose Jumwa, Senior Cost Consultant at Mace YMR. Please give a round of applause. Rose.
Okay, so ladies and gentlemen, good afternoon. I hope you've had a good day so far. You've enjoyed the presenters that have come before me. My name is Rose Njumwa. I'm a registered quantity surveyor, been practicing right here in Kenya for the last maybe slightly more than 13 years. I'm currently a senior cost consultant at Mace YMR. So thank you very much for the opportunity to share on aluminum glazed facades and from a quantity surveyor's point of view. I know many times we hear from designers, we hear from marketers, we hear from engineers, but rarely do we hear from QSs. And just to know what is it that we look at when we want to price for these systems, or what is it that, some of the parameters that are important for us to get the right costs when we go out to market. So I hope after this I'll be able to highlight some of those things, and hopefully we can get better specifications when we go out to the market to get prices. So just to give you a bit of background, I know in the recent past, most of us walking around Nairobi, we've noticed an increase in modern high-rise buildings and commercial buildings in Nairobi and even other cities, major cities outside Nairobi. And this has led to a high demand for sleek buildings, for energy-efficient facades, and that is where aluminum glazed facades come in. They are very beautiful. We all agree that they are aesthetically appealing, they're energy efficient, they are functional, and so they have gained popularity. And so with that increase in use of these facade systems, we as quantity surveyors have a very key role to play in just planning and controlling of the costs, so that once we move to construction, we're able to manage the cost and the project is able to proceed. We know most times if the budget is not right, if the budget is not met, chances are the projects are either going to stall or stop all together. So what is an aluminum glazed facade? I'm sure you know what this is, but just to remind you that it's a curtain wall system that combines the use of aluminum frames and glass infills. So this is where you have frames running horizontally and vertically, and you also have glass infills. So these systems provide daylighting, and that's why they have become very popular. They are weather resistant, they're very beautiful to look at, it's aesthetically appealing, And many people, you want, when you're on the outside looking at your building, you're looking at something that looks very beautiful, something that is a landmark, something that, when you tell people you're the one who designed this building, you actually feel proud of yourself. And these are very common in commercial buildings like office towers, malls, airports, etc. So what are the main glazed systems in Kenya? We have 3 major systems that we mostly use. One of them is the stick-built system. And in this system, the assembling is done on site. So you have the transoms and mullions fixed in position. Then you bring your glass infills and fill into the grid that has been created by the aluminum frames. This system is commonly used in buildings that are low-rise. Another very common system that we have is the unitized system. So with the unitized system, it's fully assembled in the factory. Then the system is shipped to the site and installed into position. So you find that this system is very efficient. In terms of installation, it's very quick to install. The other third common system that we have is semi-unitized system. So the semi-unitized system is a combination of the stick-built and the unitized system. Here, it combines both site fabrication and the on-site assembly. So I did mention that the unitized system is very common in high-rise buildings. Then the semi-unitized is now common in buildings between mid-rise to high-rise. And besides where to apply that in the different systems in terms of the height of the building, the system you want to use will also be dependent on the design complexity. The more complex the design, you may want to lean on a certain system. And again, depending on your budget, because all these systems have different budgets. I'll highlight on the current market rates later, but you'll see that the 3 systems have different rates. So having mentioned that, what are the things that we look at when we want to price for these systems? The first thing we look at is the design and the performance. And here we look, for example, the glass. We want to know, is it single glazed? Is it double glazed? Is it laminated? Is it low E? So what is the type of glazing that you want to use on your project? The other thing we consider is the aluminum profiles. So the size of the profile, the thickness of the profile, the finish of the profile. Is it powder coated? Is it anodized? All these have different rates. The other thing we look at is the concentration of transoms and mullions per square meter. You find that some designers will want to have many transoms and mullions concentrated per square meter, and that raises the cost of the system, as opposed to having maybe bigger spaces in between the members. The other very important aspect that we consider is fixing accessories. I know many people don't think fixing accessories is something of importance, but it is. It will determine the longevity of the system, the functionality of the system. And so here we look at what is the quality of the handles, the locks, the hinges, the EPDM gaskets. Again, is the project located in a marine environment? Because if it is, then you need a product that is corrosion resistant. Okay. The other thing we look at is the performance specifications of the system. What is the wind load bearing? What is the thermal and acoustic properties of the system that is being designed? So the second thing that we consider is the source of materials. We have locally available materials, and we have materials that are imported. So for your project, for the particular project that you're working on, where do you intend to source the materials? If you're going to source, say, from UAE or China or South Africa, wherever it is, you need to know what are the exchange rates, what are the shipping costs, what are the import duties, the VAT, because all these things will impact on the final cost of the product. So it's very important to know where are you sourcing your materials. The third thing is the fabrication and project factors. So again, we consider the complexity of the facade geometry. You find there are buildings which are very regular shaped, and so there's not much cutting and wastage. But if your if your design is irregular shaped or some interesting shapes, then you'll have more cutting and therefore more wastage and therefore higher cost. So it's just something you need to factor in when pricing. Again, we look at the site logistics. Will you need a scaffolding for your project? How high will it be? Or do you need a crane? Do you have access to site for the crane? So all these things, again, they build up on the cost. We also look at the labor skill level. Aluminum facade system, not everyone can do the installation, not everyone can do the fabrication. So you need to have someone that is very skilled. And of course, the better the skill, the faster the installation, and definitely the higher the cost you will have to pay for that. Yeah, so the other thing we look at is the location of the project. Like I mentioned before, where is the project located? Is it a humid area or is it a highland area? Different locations will need different materials and therefore different prices. We also consider the warranties and the quality of assurance that is being given by suppliers. It's recommended that, or rather required that every supplier will give you a warranty. But what's the period of the warranty that you're getting? Is it the kind of period that you want or not? So it's something to consider when you're pricing for the system. So having said that, just to run you through the current market rates in Kenya. So for the stick-built system, this is the most cost-effective system that we have currently in the country. It ranges from 18,000 to 24,000 per square meter for supply and install. And this is roughly $140 to $185 per square meter. Then we have the unitized system, which ranges from 22,000 to 30,000 per square meter. Again, roughly $170 to $230 per square meter, supply and install. We have the semi-unitized system. I had mentioned that this combines both the stick-built and the unitized system. Again, it's an average of the two, so it ranges from 20 to 26,000 Kenya shillings per square meter. That is $150 to $200 per square meter. You may want to use structural glazing in your system. So structural glazing comes at a slightly higher cost, and that ranges from 25,000 to 32,000 Kenya shillings per square meter, which is again $190 to $245 per square meter. You may also want to use double glazed low E glass. Again, you'll need to add a markup to whatever system you're choosing by, say, 3,000 to 5,000 Kenya shillings per square meter, which again is roughly $23 to $38 per square meter. So I hope that gives you a rough idea of what the current market rates are and therefore advises you on what system to go for. Okay, so then we have risks that in every project there are risks. And so even with the facades, we have risks that I just want to highlight 4 risks and how to mitigate these risks so that we have an easy project on site. So one of the main risks is normally design variance. Most of the times you find that we move to construction without having locked the design. And so during construction stage, you find there are so many design changes, and with design changes comes variation, costs, and many times the cost is varying upwards, not downwards, which is something many clients don't like to hear about. They're happy to hear of costs coming down, but not costs going up. So to mitigate this risk, it's advisable to finalize on your designs and the price prior to construction. The other risk is lack of mock-ups and samples. I find it unfortunate that sometimes we move to construction without having seen samples from the contractors or without having done mock-up so that we know the system we are choosing, how does it look like? Is the performance what we want? So to mitigate disappointment during construction, it's advisable have samples delivered by the subcontractors or the contractor, whoever will be doing the installation. They can, give a number of samples and you choose which sample works best for you. They can also do mock-ups and you choose and agree that this is what I want to go for before you can procure and even before you can commence construction on site. Another risk is currency fluctuations. Now, I know budget is always something tight when we go, when we are in all the construction projects. We have, especially when you tell a client that the budget is this amount, they stick to it and they don't want to hear any changes. But again, fluctuations are inevitable. Sometimes it's something we can't control because it depends on the economy, the market, how the market is behaving. And so just to mitigate this and just to help yourself later on during construction, it's advisable to have an allowance for, for contingency, just in case the market is not as friendly as you thought it would be. So your project will not stall. The other risk is lack of warranties. So again, it's very prudent to ask your supplier what the warranties are, what the maintenance cost will be. Will they be maintaining the facade maybe for a period of time during the DLP period maybe? So it's very important to have this information way before you choose the product and move to construction. So having said that, I have a few recommendations for us to just have better projects. So one of the recommendations is that have a facade engineer. On every project that you're going to do with, say, an aluminum glazed facade, it's very, very prudent to engage a facade engineer. I know in Kenya, facade engineers are not very common. It's something that is now coming in, but has not been there in the past. So if you're going to have an aluminum glazed facade, please engage a facade engineer. They will work on the design so that you get a proper design, you get a building that is functional, and a building that is going to serve you for a long period of time. It's also advisable to have a quantity surveyor early on in the project so that we can work on the costs and lock in the cost before we move to construction and are met with many variations and cause a project to stall. So have a QS early on in the project, let them get the right cost for you. Third thing, you can do your benchmarking. This is where you look around the buildings that have been done, see if there is any facade that you want to replicate maybe, or just to use. Get to know what were the dynamics in the construction of that facade, so that moving forward, going into your project, you know what to expect. You know the costs, you know the challenges that were probably experienced in the other construction, and what to avoid. The other recommendation is contingencies. I've talked about this before. So have contingencies and price escalation just in your budget, just in case there are changes in the market. And lastly, look at quality and performance rather than cost, because many times you want to go for the cheapest system without looking at the quality of the system, without looking at the performance of the system. And you may think you're going for a cheap system in the initial, but you never know what the maintenance costs will be. You don't know what how much it's going to cost you in just maintaining that system. So you'd rather go for maybe a slightly more expensive system in the beginning, but save yourself the hassle of repairs or the hassle of maintenance moving forward. So I hope with that short presentation, I have been able to highlight some of the things that we quantity surveyors consider when we are pricing. And also hopefully moving forward, we can get better designs from the architects and from the engineers so that even when we go to the market, we know the specifications that we are looking at, the systems that we are looking at, and that will help us get the right prices from the market. So thank you very much for listening.
Thank you. Thank you, Rose. That was a very informative and cautious design approach presentation. Thank you. I'd like to call on Mr. Daniel Adsman to present. He is the head of Custom Engineering International at Schüco. Thank you. Please give him a round of applause.
Okay, thanks for the introduction and thanks for the invitation to this conference. It's an honor for me to speak in front of you. It's my first time to be in Africa, and I like it very much. Thank you very much. Maybe a few things about myself. So I'm, as you already mentioned, I'm head of custom engineering at Schüco in Bielefeld in Germany. But next to that, I'm also a professor at a university where I'm running a facade master course, an international facade master course. And if any one of you is interested in facade education here in Africa, you can talk later to me in the break. So I'm always interested in talking about that. Okay, but today I will tell you a bit about my department at Schüco. So it's called Global Custom Engineering. And when you look outside at our booth and also on our website, you see that Schüco has a lot of catalog systems. You know, we can provide everything from facades to windows to doors. But sometimes you might have specific projects where that have specific needs. And then we come into play because we are there to adapt our standard systems, so that they fit to your specific project needs. To do so, we are quite a big team of technical engineers, project managers, and different services. So we are about 200 designers worldwide, and we are based in several locations. Our main location is in Bielefeld, Germany, as I said, but we also have people in Bangalore, we also have people sitting in China, and also there are more entities to come. How do we work is our main clients are the metal fabricators, but also we help architects, and we help in different stages of the project. So first of all, we help our metal fabricators when they are tendering for a project. So keep in mind, we work on special projects. So first of all, we design our clients to find the right solution for a project so that they really can bid for a project with that. If the metal fabricator wins the project, we are going further in the design, and we are going very deep into detail and provide our clients also fabrication documents so that they can finally easily fabricate and install these special solutions. There are different parameters why you might need customized designs for your project. So the first the first special demand could be that you have a project with a very special geometry. You see that here in that building, that's a building in the Netherlands where a stick construction was used here, but you see that in the front of that building, you have a very strange curvature of that facade. You cannot solve that with our standard systems. And then we adopted our standard system, so here you see some details of that. It's still a stick construction, but with hinges in there so that you can have a lot of variation, that you can meet these different geometries that are needed. Another special demand could be special technical requirements. And that's, you see, for a building like that. So we very often work for high-rise buildings all over the world. And for that, for example, you might have special recommendations on high wind loads. You will have maybe different movements in the building because of earthquakes or because of very slim high-rise buildings. And there could also be special security topics. Then design, for example, facades like that. So that's a standard unitized facade. But what you can see there is a huge gap between the different units, so to accommodate huge building movement. That's just one example of that. Then it might also be that you have special functions to be integrated in the facade. So that's a very interesting building here. There a unitized facade was designed. That's something that we did very much in the past. Today this is a bit less because of all these sustainability talks, so we try to reduce materials. But in the past, very often unitized facades were designed, and this were done in our department. But there could also be other special functions that might be necessary and that you don't find in the catalogs of the system suppliers. Also, Schüco in the past mainly worked for European countries, but in the last 10 years, I would say, we always go more and more to special markets where, for example, it might be necessary to do value engineering. So here for example, we did that for some Indian projects. There you have to, of course, comply to the local standards. And these are also very cost-sensitive markets. You might also face this issue here in Africa. And then we take our standard systems and bring that down to the necessary what you need, so a very cost-effective design, but still it complies with the requirements that are relevant for the specific project. So this is what we do very much at the moment for our international markets. And the last project-specific demand that brings project to us, and this I also want to highlight today, is this topic of sustainability. It's a very prominent topic at the moment, and Schüco takes very much care of that. And especially in our department, we help investors, we help clients, for example, when they want to achieve high sustainability ratings. For example, with the programs LEED and BREEAM, we also have projects that were certified with cradle-to-cradle certificate, or also the well-being certificate. And the main aim with that is bringing down the carbon emissions of the building and the facades. But I will show you an example of that also later. In general, we can say with this lot of amounts of engineers, we work on a lot of projects. So in 2024, for example, we worked on 350 successful completed projects in 40 different countries all over the world. And we are not just working on facades. So facades is our main topic we are dealing with. Most of them are unitized facades, but we also work on stick constructions. We design special sliding systems, window solutions, door solutions, and so on and so on. Okay, now I want to go a bit more into detail how our work looks like. In general, you can explain it like that. Here on that slide, you see two different details. On the left side, you see a standard system out of our catalogs. And when a client comes to us and wants to have a kind of special design, first what we do is we look into our catalogs and look if we have something similar that nearly fulfills the need. Then we adapt our standard systems to these special needs. And this is what you see now on the right side. So we enlarged here the profiles. We have a bigger size of the profile, but the standard details like insulation bars, gaskets, and so on, we took from our systems. And that mainly explains how we work. This looks now very simple, but I will go with you now through a few reference projects, and there you can also see how crazy it can get in our department. The first reference project I want to highlight is this one here. That's a project that's called the Kula Tower. It's in Belgrade in Serbia. It was designed by the architect SOM. And here in that image, you can already see it gets a bit crazy, but you even don't see how crazy it really is. You see that much better in that rendering. So you see there are some areas with a very straight facade, but you can also see that there are areas with a huge curvature. You have inclined to the outside facades, inclined to the inside facades, and the biggest thing is that everything comes somewhere together. When we get a project like that, the first thing is what we are doing, we sit down and we think about, okay, does something that we did in the past comes into consideration to solve that facade? Here for that facade, it was very hard to find something, something similar that we did already. Then we had a very close check of the geometry, and this is what you see here at the bottom, at the left side. You see at the very left side, you see the initial design of the architect, and there you see some different colored units, and you can imagine the most difficult units are the red ones, what you see there. As you have a huge curvature there, these red ones would just be possible in the initial design with hot bended glass and also hot bended profiles. And that's something what makes it very expensive. What we did then was we have also a few computational designers in our department, and they analyzed this geometry and did a topology optimization. And then they came up with that design in the middle. And there you see with a small change in geometry that you even don't recognize when you look at the building, we were possible to value engineer that facade to a facade where you don't need hot bended glass and hot bended profiles anymore. So this makes the facade much cheaper. Nevertheless, when you look on the design of that facade, you still see that it's a very, very complicated unitized facade. So this was one of the most complicated facades that was designed in my department in the past. And you see that, so you have a lot of aluminum there, but for us from Schüco it's not bad because we are selling aluminum. But on the other hand, you also have to do a lot of flexible parts in there so that you can adapt to the specific needs also on the building side. You know, because this you also have to keep in mind when you, for a complex building like that, of course you get very good layout plans of that building and very good plans of the primary structure. But when you come to building side, often it looks totally different. And then it must be also possible to adjust your facade to the conditions on site. We also did some projects in the African area. This project was already highlighted by our friends from Prime Aluminium. So that's a Kigali Financial Center that is at the moment under construction. The architect is Pride Architects, consultant Meinert Facade Technology, and facade, as I said, Prime Aluminium. When you look at that building, it's a typical unitized facade project because you have a lot of same units or facades all around the building. So it's very good for prefabrication, where unitized facades are really made for. And that's now the design of the facade. So that's a facade where I would say this is very much value engineered. So that means it's broken down to the necessary that you really need for the project. And that's really what sometimes also cries for customized solutions, you know, because there, when you have a lot of square meters of facades around your building, then it might be necessary really to look on the project specific needs and to design the facades, especially according to that. Because here you get the best quality for the best price that you can get. But where you have to be sure with that is you also need a good partner, a good fabricator for that, because unitized facade is also a bit more advanced than a stick construction. By the way, the time that I see there, is that right? Do I still have 12 minutes? Okay, that's great. Then I can go into detail. That's good. Good. Here again, there is a more complex solution, and this is also an African project. So it's the telecom headquarters, the new telecom headquarters in Egypt. That's also under construction. And this is also very, very interesting building that also has a very interesting details. What you see there on the side of that building, that's a more a standard facade with lamellas at the outside. But there in this entrance area, there you have a complex facade design with a lot of different, with a lot of different curvatures that all get together. In the past, this would have been a very, very difficult special design. Meanwhile, we can say from Schüco, we have a system for that, a system solution that you can easily adapt for things like that. The solution that I want to highlight here is the product Grid to Shell. And Grid to Shell was initially designed for skylights, for crazy roof constructions. And meanwhile, you can also use that for facades. It's very parametric. It's an unsupported facade, so it's a self-supported structure, so you don't need columns or pillars in the middle. It works perfectly with structural glazing. And also what for us is very much important is the second point at the bottom. It's a 3-layer drainage principle. So this is what we always use for nearly all of our constructions. So to make it easily done that water gets into the system, gets easily out of the system, and is never dripping down into the building, because this you don't want to have in a roof construction. When you look at that slide, it looks like it's not a so difficult project, because you don't have too many articles you have to consider. The main things is you have, wait, I have here the pointer. You have here on, whoops, how is that working here? Like that. You have here a node that you have in the middle of the construction. Then you have here the main profiles, and these profiles are nearly always the same in the whole construction. And then you have some specific bolts that you need to combine these profiles with these node points. And then you can bring that into several, from several steps, you build that together. So the first step is you have to connect the node points together to the profiles. Then you use the bolts to screw everything together. Then you have a gasket principle, so you have some specific gasket pieces that you put on top of that. Then there comes the glazing support. And then you can install the glazing. And then the only thing that you have to do is you have to seal all the gaps very carefully. And then finally, a node point looks like that. What you see here quite well on that side, that's this drainage principle that we are using there. And you have these adapters to fix the glasses there. And these are also necessary to adjust to the different geometries. So you use these standard profiles. These profiles are all normal profiles. The main issue is always the nodes. So the nodes are really there's where the know-how is in there. For the production of the nodes, you really need a very good 3D model, and then you can design the nodes especially to the needs that you have on your project. What is important is the Grid to Shell is not a product like a stick construction where you can say, okay, you assemble that all on site. What you do with that is you have to assemble everything of that at the ground, and then you lift that up. You can do that in different parts, and then you have to connect the parts on site. I will show you a movie, a short movie of a production in a few seconds, and then you will see much better how this is done. Here you see then how this looks like on the building site when the parts gets delivered there. So here you need to see the different node points. Here you see the aluminum profiles. And the rest is then, there you see how the facade is constructed. And you first construct the primary structure, so this grid shells, and then the glazing is done when the grid is installed already. And here you see now a small movie from a building site. So here you see now the grid shell that was fabricated at the bottom in different parts. Then you lift that with a crane in the right position. and then you have connect the special points all together. And when you do that quite carefully, you can build very nice projects like this here. That's an example from Novosibirsk, where we used that. And meanwhile, we have several projects in planning where we will use that system. So that's the most complex product we have at the moment. The issue with that is, with that product, you need a very good facade engineering capacities, but this we also provide from Schüco. So when you have a product, when you have a project like that, we will support you very much with that. But we don't do just complicated facades and so on. This I told you at the beginning. So one other great project we supported here in Africa is the Dian Fossey Gorilla Fund Research Center in Rwanda in Africa. The architect was the Mass Design Group, and facade fabricator was Baraka Properties Limited. And for Schüco, this was a very interesting project because it's of course a very nice design and a very nice landmark project. The works from our department were not so complicated here, but this is also what we are doing. You know, if you have a Windows system that should be designed for a special project, we also support that. You know, because this is also something where we can do value engineering. In areas like that, you don't need much thermal insulation. So you see here there's still double glazing used, but the window systems are thermally uninsulated. So that's also what we provide. So our services go really from the most difficult projects to more value engineering projects. At the end of my presentation, I want to show you something. I highlighted also this topic of sustainability. And this is what we took care very much about the last, we already deal since 10 years with that project, but we increased our view of this topic in the last 5 years, I would say. And that's a very interesting product or it's a vision. It's not a product that we sell already, but we have always in January, we have a big Bau exhibition, a building exhibition in Munich. And that's our main fair where we present our new products and also our visions for the future. This time we highlighted this product, and this is called the AW Circular. That's a window that is developed for bringing down the carbon emissions as much as possible. So what we did here was we tried to use as much recycled products or reused products as possible, for example. For example, we made a collaboration there with the glass industry, and what you see here in that mock-up here, in that image, we used here a glass that is 100% reused. So what does that mean? We used the insulation glass from an old building. We cut out the spacer material, and we cleaned the glass, and then we made out of that a new insulation glass. Of course, you cannot expect that the view through that glass is so clear than from a new built glass, but when you have had the chance to look at this mock-up, you would nearly see that you don't see much difference to a new glass. And the same we also do with other component in that window. For example, the aluminium that is used there is our ultra low carbon aluminium. So it's a specially produced aluminium with a very low carbon footprint. Then we used their gaskets, recycled gaskets, or gaskets built from recycled EPDM, for example. We also used their, and this is also quite interesting, we used their hinges, so to open the windows, also from old products that we refurbished from old products. So these are really reused hinges. Furthermore, we developed a new insulation area here, also with reused articles that are installed in that insulation area, so also to bring down the carbon footprint. And we are meanwhile in that status, so in January we said, okay, that's something really for the future. You cannot order this with us. At the building exhibition in Munich, we had very interesting requests for that. And for special projects, we are now nearly in the stage where we can provide most of these things that you see here on that slide. Okay, this is what I wanted to show you today. Thanks for your attention, and I'm looking forward to fruitful conversations with you in the break. Thank you very much.
Okay, our next speaker is also our keynote speaker for the day. It's architect Sanjeev Mehta, who is from Bombay, along with Deep Bhanushali. He's from Ethic Architects and Associates, and he is also a principal architect. The company that you've been asking me, Ethic Architects, that's me, and this is Mr. Sanjeev Mehta from Ethic Architects and Associates, and he's also a keynote speaker presenting to us some nice projects, which we'll be able to have a look at, and some you've already seen here. So please give him a round of applause, please.
Thank you, Jay. Thanks for the brief about our projects, what we are doing. First of all, let me thank Zach for organizing this kind of a great forum. I think it's one of a great forum which all the designers, architects, suppliers, promoters, they come together, exchange their idea, and I think that's one of the great way to make it the thing more innovative. We are basically based in Bombay. We have an office in Nairobi, in Pune, and a consortium office in Dubai. We have completed more than 250 projects in a span of roughly say around 20 years. Today what we'll be showcasing is a 6th project. Now because of the time constraint, we'll be slightly moving fast, but we'll be showing the different variety of the project, all in a different versatile in nature, and every project has its own story which is related to the climatic condition, to the kind of the aesthetic which you would like to prepare it. So I would start with one of the, the first project which we have done in India. So this is one of the project which is approximately around 2 million square feet. What we are trying to do is there are 6 projects what we will be showcasing. Few are designed, few are under construction, and few are completed. So this is one of the project which is approximately 2 million square feet, and it's a mixed-use development which consists of 7 theaters, a large-scale office, a 4-star category hotel, a shopping center, concert area, and much more over here. So this project is absolutely completed, and it is a detailed storyline behind it to make the project more cost effective but still aesthetically look better. Today being the project given to us, like the topic given to us is like, the aesthetic and the facade, how innovative it can be done to look the overall difference in the skyline. So this is the project we would like to just showcase it in the first part of it. This is the second one which is under construction, and here we are trying to follow more of a parametric architecture. The third, we are infusing slightly of a green building in the structure which is in a proposed stage and the design has been approved. So this is going to be the third thing. This are the project which have been completed in Nairobi. So this is from 2-bedroom, 3-bedroom, 4-bedroom, 5-bedroom apartment, and approximately 500,000 square feet of the project which is already completed over here. It's a residential project. This is the one which is also on a General Mathanga Road. This is also a completed project, but this is a high-end project with one single apartment on every floor, practically 5,500 square feet of each apartment, and 33 apartments and 3 towers. And the last, what we would like to showcase is we are doing one of the 5-star, and probably it's going to be the biggest in Nairobi with a 400-room service apartment and a lot of other activities over here. So yes. So this is the first project, Entral, which is completed, and it is in Maharashtra in India. The basic concept planning is like bridging the gap with the parametric architecture and the modern structure, how we are doing it, with all the different activity, how we have infused the activity with respect to the aesthetic, the costing, and the other kind of a parametric architecture, which is bridging the gap of the concept and the execution level. So when given a project to us, we always first design in a way with the basic form process is like form follows architecture. So like form follows function. The first on the top what you see is the basic plot was given with an intensity that we need to complete with so many activities out over here. So what we try to do is we try to create bifurcation in the plot, create a road kind of a thing in between, and created the project in such a way that both the activities are merged together and it looked like a one single entity. So this is the overall layout of it. The central part, which we try to create a central aisle with a wide walkway, it becomes like a nice street and a shopping area at the lower level. So this was the basic free flow structure which we have created to give more impact, where more gathering of the people come at the lower area, and the upper areas are the offices and the hotels and everything. Now, when we come to the scheme, the major concern was how we going to bridge the gap between so many of the activity. Even there are 6 kind of a different activity, the whole concept was to make it and fuse it and look like one. So we started with the thought process of first with the one with a circle, and then we came to a conclusion that when we create a circle thing, there's a lot of gap in between. Then slowly we start develop to the other function, and then we came to the hexagonal structure over here, and ultimately the whole complex we have bound together in such a way that it gives me a honeycomb structure which is integrated, and it looks like a one single mass of a structure. So this is the look and feel of the structure, which is the rendered image. And at the bottom level, we have created the longest skyline of that particular area, which is binding both the activity with a nice skylight on the top. So these are some of the sections which we are created with an MS framing structure, which gives a nice elevational feature aesthetically. Also, how to take care of the maintenance part also. So we have taken, so the way it was detailed out, it was like even for the maintenance part of it, it became much easier. We have taken individual facades with this kind of a detailed sections with a more of a perforation to create a light emission goes less inside, plus still the brightness of the structure is there, and I get a lot of advantage for my air conditioning and the other. So these are some of the schematic section, how we have bounded the facade with a metal framing structure. Now, this was the central spine which we wanted to connect with a parametric node of an architecture, which in the previous presentation we saw that how it's bound. So we have actually done it at the site in a way that it looks one particular single structure in a wavy form and covered with a polycarbonate sheet to get a maximum light infused in it. So this is the one which is an actual photograph, like it's been covered with a complete central spine with the space frame and a polycarbonate sheet. And certain places to have that strength in the structure, we created a nice architecture feature, which is showcasing like a more like an iconic thing coming right from the center. This is the parametric node of an architecture, which we have tried to create for the space frame in the center. And here we have tried and given all the joints on a nut bolt system, like in the previous presentation what we did. So there's a lot of room for the expansion and the contraction of the structure without formation of any crack anywhere. So these are some of the rendered image which actually at the site is there, and this is the tree which is giving the most strength to the structure. So this was the design aesthetic of the overall project, like combining, forming a one function together. So these are some of the renders. And the thing what you see is an actual photograph which is already completed right now with the same thing what you have shown. And this is the night vision which really highlights and gives the impact on the structure. So this is on the right side what you see is the executed, and on the left side what you see was proposed. So basically we try to follow the form and functions, and that's the reason we created the whole mass which looked like one, but with a different 6 entity, different functions over there. Now for the second project, I would invite Deep, my colleague. This is also a commercial structure with a mixed-use development, but completely done in a parametric architecture. So yeah, Deep.
So this was the project, commercial building designed on quite a tight plot, I would say, of around 4,000 square meter. The building is around 150 meter tall, currently under construction. So if I tell you the basic zoning of, so we have parking floors on the lower, and we have around 25 commercial offices on the top. And usually, like when we design a elevation, specifically a high-rise building, so always there are like, it is divided into 3 parts: the eye level experience, the central mass, and the crowning of the building. So like when we were developing the form, as the plot was in a L shape, so when you see from the road, you see like two facades which were visible. So then we developed a concept of a wing, like a building is designed in the shape of a wing. And when we see the lower part, we followed some elliptical jalis which were made in aluminum, and the backdrop what you see was done in the louvers which were in the darker in shade, so your front aluminum parts lights up. And this was the second project, the Alturia Towers. So this was designed basically on a concept of biophilic architecture. It is a 180-meter tall tower currently under construction right now. So when we were developing a mass, so we decided to go a bit, your building goes in a tapering form at the top. And when we were designing, each and every office has a terrace in front. So as it is designed in Pune in India, the temperatures are quite hot there. So we provided almost all the balconies in wrapping around the office spaces. So this gives, this avoids the direct light hitting your facade. And the facade was also designed in such a way that you have a green balcony. So like you're working in your office, you see a green balcony and you have a good view in front of each and every desk. And if we see the overall form of the building, so the aluminum fins, what you see, were inspired from the branches of a leaf wrapping around the building. And like this was the final output, what currently we are constructing on the site.
Pradeep, very much. These are the three projects of the commercial which we are doing in India. So every project is its own different story. So whenever we design, it is always a different concept. It's not going to be like a repetition of one to the other concept to the third concept. Now this project we have completed in Nairobi, which is like in a neoclassical style. Absolutely done in a proper proportion with three different concepts of the elevation. So like when we got this project, the same thing, the plot to be triangle on one side there was the road and the other side was a pretty decent green area view. So we decided to go with the project in a different way of like designing first the whole mass on the taking on the roadside one of the structure, but that later we realized that the most of the view which is on the rear side, it is getting minimized. The reason then we took this two kind of a structure together and then ultimately we combined them with the central axis, and ultimately the plan which we designed was forming the clear neoclassical style of an elevation in a nice curvature formation, so which gives a lot of impact when the person is traveling from the road, and there's a lot of foreground has been created by pushing the whole structure behind. And it's been designed in a proper central axis so that the wind movement is pretty clear in the central corridor area. So this was the building facade which was again designed with the same concept of like three different parts. When you see from the eye level, that's one level. When you see at a certain thing, that it becomes the center mass, and then the crowning feature where the overall mass is going to be seen. The whole building and the project has been pushed behind by 80 feet so that the front part is much more impact and the elevation look more grandeur. So these are the actual and the final formation of the elevational design with a central pediment feature, entablature, nice fluting, then piers and pediment. It's been created in proper classical style. A beautiful nice entrance porch we have created with the proper proportions of the grills and the patterns in the center, with a center atrium height of giving almost 45 feet of a central atrium what we have given over here. And these are some of the actual rendered, the actual photographs on the terrace, all the amenity, what we have created. This is an actual photograph of what we have done and what is it actual right now. And this is the, on the right side, what you see is a rendered image, on the left side is an actual facade. So the overall proportion and the mass what we try and create in every project, not only in single classical project, but every project is one of its kind and it has its own different stories. Now this is one of the project which is again completed in Nairobi. This is the 3 towers, the same, it was a nice rectangular plot, again with the same lot of feasibility of the wind blocking and all that. So we try and create it first the plain mass, the plain mass over here. Then we broke the whole project into 3 different parts and ultimately giving a project to is nice for the wind movement from the center part, a curvature on it, and created a 3 different separate oval with 1 single apartment in every floor. So the overall the project consists of 33 apartments. And this was the concept like forming a nice proper axis and all the balanced circulation has been taken from the center part. And this is the overall final overall layout with 3 oval structure formation with a beautiful thing, all facing the different views from the back and the front side, and practically all the rooms are cross ventilated. So this was how the basic concept and the thought process of the planning went. It was a nice rectangle plot with a contour with a steep development. The overall project massing was, this is the one which we are able to do it. And then we broke it into different layers of the parking statements. And then 3 towers separately we have connected in this way. And ultimately we went to formation of a different form of an oval. So this is the final outcome of the product which we have designed, and it's already completed over here in Nairobi. These are some of the renders. And on the terrace, we have given the maximum activities as well as the lower floor on the podium. All the activities have been taken care. Now, this is the very interesting project which we are doing at Karuna in Nairobi. This is a 400-bedroom service apartment, and probably that's going to be the largest of Nairobi, this development, which Deep will be explaining you. It consists of shopping, a huge banquets, and service apartments.
Yeah, so this was a mixed-use building currently what we are doing in Nairobi. This has around 400 rooms of serviced apartments plus hotel rooms. The lower floor have banqueting spaces and some shopping spaces on the ground floors. So like this was also designed on quite a crunch plot, and currently it is around 140 meter what we are going, the height of the overall height of the building. So like usually like it was a similar concept as we discussed earlier, like when we are designing a high-rise building. So overall the lower part, the middle part and the top part, the crowning part is designed in like equally proportionated ways. And like when we were designing this facade, so basically it was a mixture of squares arranged in asymmetrical form, and we had break this form with some curvilinear terraces at the regular intervals, and to highlight the white boxes what you see in the elevation, we had a backdrop of a black glass which are your hotel rooms, and this was the drop-off areas for the hotels and the other things.
Yeah. So this is like some of the project what we have displayed it today, and like every project, if you see, is more versatile in nature. And yes, we definitely believe in form follows function, and that's the reason every project, whatever you see, the plan and the development and the thought process, the story behind it is always different, but yes, the aesthetic plays an equal role of it. And that was the topic of today, that how we are changing the skyline with a different kind of an elevation look and making a facade more beautiful with the same cost and not increasing the cost just for the aesthetic part of it. Now, aesthetic plays really more important role in architecture, that everyone knows it. So this was the basic concept of popping out of the different terraces, making it more iconic in nature. So always when we design singular plot or in a mass housing, we always try and see that every project become iconic in nature, and it become much more easier to take it for the maintenance part of it. So you see that all the different project has different storyline. So we are sure that everyone has liked our presentation, and yes, any questions or something, we are welcome, and we definitely would like to join everyone during the break time for the further conversation. Thank you.
Thanks. Thank you, Sanjeev bhai, Deep. That was very.
Thank you, Jay. Thank you.
Thanks. This was Ethic Architects and Associates presenting to us our projects. At least I am involved in them. I'd like to call upon Mr. Osama Wardani, Market Development Manager, AIS Division, Kurare. Please give him a round of applause. Mr. Osama from Kurare. Thanks.
Thank you.
Thanks.
Good afternoon, everyone. My name is Osama Wardani. As you could see from the picture, that's made by AI. It's always tricky. You don't get the same thing. I'm the Market Development Manager for Kurare in the GCC plus Egypt, and if I do good, maybe Kenya as well. This is my first time, by the way, speaking on a stage, and I'm a bit nervous, but I hear from most of the speakers it's a bit normal, but I'll do my best. So, Kurare is a Japanese Japanese specialty chemicals company, and they're involved in so many areas and so many businesses. I don't even know half of them, but just to give you some examples, water solubles, we occupy almost 80% of the global share of cleaning detergents for dishwashers and clothes also washing. The blue thing you see in your Persil, that's made by us. When it comes also to biodegradable plastics, dental equipment, and again, many more. But when it comes to the construction, we have two brands. Okay, where is the clicker? I'll use this one. We have our two brands, the Trosifol brand and the Centriglass. So Trosifol is PVP, our PVP line. Centriglass is the Ionoplast, which was acquired from DuPont. Maybe DuPont is a bit older name when it comes to the chemicals, but now we have these two products. And we belong to the, what we call AIS division, Advanced Interlayer Solutions. This is our locations on a global scale for Europe, Middle East, and Africa. We are operating from Germany and Czech Republic. That's where our production facilities are. But usually we would supply directly to customers, and wherever they are, we can just order it in from Germany. So first thing, we will talk about what is laminated safety glass, but in order to answer that, I think we need to talk about the types of glass and the failure models for those glass. So the most basic form of glass is the annealed glass, and this is just got out from the manufacturing, basically. It has not gone under any processing or any processes yet, and it's still very fragile, very weak. But if it breaks, also it would break into those big, sharp splinters, as you could see. Yeah, this is here. The second type is the tempered glass. So tempered glass is annealed glass that is gone through the process of tempering. They expose it, I think, to 650 or 700 degrees, and then it makes the glass much stronger. And if it breaks, it would break into those stone-sized pieces. The last one, and that's where we come in, is the laminated glass. As you can see, if the glass is broken, the glass will be retained on itself through the interlayer, actually. But we will discuss the interlayer types more later. So the process of lamination is basically bonding two glass panels together. Between them, there is an interlayer. There are different types of interlayers. What we supply is, as I mentioned, the PVPs, different types, and we will discuss those, and then the Centriglass, which is a structural interlayer. Why is it important? Because in some situations, as you can see here, there is a very excited fan in a very full stadium who probably was wearing a ring and broke the glass. And I could imagine a different scenario if there was no laminated glass, or actually this particular interlayer, which we will discuss more. But it could have ended without that smile. I think you've seen him smile, but it could have really have ended in a not very good way. Okay, so our portfolio fits all your needs. Basically, these interlayers can come to help you in many areas to give your glass a better performance. But again, the standard one is always the safety, is the glass retention in case there was a breakage in the glass. What else can you do with that? You can also get some decorative advantage of it, because basically it comes in different colors. It can be like green, blue, or whatever. There are some special colors there, 100% opaque range. We have a stand over there. Feel free to go check them out. These interlayers also can help in increasing your noise insulation level, giving you a higher RW and STC. Also, if we think about the structural and security part, the glass, because of that structural interlayer, can behave as a structural element now. Again, it's not just the interlayer, it's all of you amazing engineers who know how to use it. But because of also the interlayer, it can help to push in that direction. Some specialized applications, UV control, we have bird-friendly glass. When it comes also to the security part, there is in ballistics, bullet-resistant, blast-resistant, or anti-intrusion. Our biggest segment is actually the automotive windshields and side windows. And again, when it comes to sustainability, we have Trusifol R3, which is a PVP that has the lowest carbon footprints. According to us and many other competitors, we have the lowest. But also, when it comes to sustainability, these structural interlayers can help you reduce glass thickness 20 to 30%. And in that way, lesser glass and lesser aluminum, that would also be helpful in calculating the total CO2 emissions. So here, this is a video on almost everything that we do, different projects on a global scale. So now I will go through some of the applications and a bit more detail about those products and where they fit in. So first of all, I mentioned the decorative interlayers. As I said before, basically they come in different colors, various ranges, and we can always customize some colors according to the needs. Also, in Germany, we have a neighboring company that's called PVP Motive. They took initiative and they started to do digital printing on these interlayers. And one of our first projects that we got in was here in Kenya. not sure what was it called, but we call it International Airport in Kenya. But again, so they do printing for the PVPs and the Sentry Glass as well. If you need any information, we can always share their details with you. Sound control interlayers. So first, let's talk about how the glass can affect the noise insulation levels. We're talking here about, if we're talking about monolithic glass, the glass thickness, thicker glass can give you higher noise insulation. The lamination would also help, and then the type of interlayer that you would use would help you to increase noise insulation levels. Now, when it comes to double glazing, it's basically all of the above, because you can laminate either side. And then also the spacer size and the type of gas or air they put inside that. We have two solutions for that. We call it the monolayer, sound control monolayer, and the multi-layer. The only difference between them is what we would recommend to use an outer panel. Basically, this is the monolayer is the answer for that, because it's one homogeneous material, while the multi-layer is a collection of 3 interlayers, and it can be mixed with other PVPs colored to give you some decorative advantage as well. Here is a comparison chart. Let's take just the last one, table. We're talking about 16 millimeter glass, monolithic. It gives about 36 dB. If you divide that by 2, you get 8 and 8. And if you use any interlayer, as you can see, it starts to increase. Sentry Glass is structural, so it's a bit stiff, so it doesn't help so much. But if you use a specialized acoustic interlayer, it gives about 41 dB. So you have 5 dB extra just with the exact same glass thickness. When it comes to UV control, so the UV spectrum is between 10 and 400 nanometers. And again, UV in general, it's always thought of as a bad thing, but in reality, it's not. Yes, it does affect some skin conditions and have some degradation on some colors or the artifacts inside, but it also helps human beings, helps living things to grow in a healthier way. So we actually developed 2 solutions here: maximum allowance and maximum protection. The maximum protection, which basically blocks full 400 nanometers of the UV wavelength, and that can be used in, again, museums, maybe some places where you really are concerned of UV. And then here on the left side, there is the maximum allowance. We have 2 interlayers, PVP and Sentry Glass, and they allow they block only 270 nanometers out of the 400, which allows more UV to enter, and it helps, again, maybe trees or animals to grow in a healthier way. In some applications or some places, they use it in long-term mental facilities or rehabs, because some of those people are not allowed to go out, or they cannot, but still UV is very vital for healthier development. Now, let's talk about the structural interlayers. So again, these are some examples of where the glass is being used as a structural element: stairs, railings, walkways. We have a project in Dubai, it's called the Sky Slide. I don't know how many of you have seen that. It's a slide outside of the building. A bit scary. I went there, so. But also, again, when we're talking about the fin systems or overhead glazing, also a structural part or structural product can be very helpful. What do you get with the structural products? Again, on top of safety, I'm going to show some videos as well, but you get sometimes lesser deflection according to calculation, and that helps in getting thinner glass construction. Does it work? Oh, cool. And then for minimal supported structures, sometimes it's needed to keep it light or as light as possible, the glass, and reducing the glass thickness can help in that. And of course, the post-breakage performance is much stronger. Here is a video. It's a bit slow, I have to say, but yeah. So this is a 19 millimeter tempered glass, which is, I've actually never seen a 19 millimeter. It's very thick, but with the right stress, or not very right, but with enough stress, it would break into those, into this, and then you have, again, a void in the facade. If we're talking about maybe 10 floors or 50 floors, this could be a problem. The broken pieces would fall on some people, pedestrians walking underneath. The next one here is done with a PVP, and it's 1010 with the 1.52 millimeter fully tempered glass. And again, the PVP is retaining the interlayer, the interlayer retaining the broken pieces on itself. But again, it's still dangerous because the void is still in the system. So using PVP is about using it in the correct application. And the last one here is done with the Centriglass, the structural interlayer. Again, same glass combination will show up soon. I told you it's very slow. I should put some music on that one. So here again, the Centriglass, you feel that the glass is resisting the impact a bit, but it's actually the interlayer that's doing that. And when by no means saying keep it like this, so you have to replace it, but it just buys you enough time to mitigate the risks of the broken glass. Another here extreme situation, because it was done by University of Munich. Some students wanted to see the limitations of the whole thing. So this is a 6 millimeter with Centriglass at 50 degrees, which is something we work with a lot in Middle East, where I come from. But so they will break the glass to just test how strong the interlayer is. How much is it going to shear from the fixation points? Is it playing? Okay. So again, 1 kilonewton is already loaded. And again, this is where the students come with their crazy ideas. They started to add more and more. I'm sure in a real life situation, no one would dare to walk on broken glass looking like this. So again, 2 kilonewton, I think they go up to 4 kilonewton. Oof. So yeah. Again, if you look even here, it's still not even touching the ground, but again, this is their work, the students. Here, this is a generic comparison between them because I'm already out of time, so I will be very quick. Centriglass shows more superiority when it comes to stiffness, tear resistance, edge stability, yellowness, and everything. But there is also a big use for PVP. It just depends on the application and the temperatures that it gets exposed to. So, okay, I'm gonna wrap up. These are some project examples. Again, the balustrade itself, again, in somewhere, I don't know where, maybe in Moscow, people leaning towards the glass. And again, if the glass is no longer there or breaks, it will have the safety that people cannot fall off this. Here also the Louis Vuitton building in France, it shows also that the minimal or lessening glass thickness can help in making these unique designs. This is also a project that we had in Dubai with high noise insulation levels. So yeah, it shows that basically the requirement was again, I think 45 dBs, and because these two towers are between, there is a main road between them, and if you ever been in Dubai, everybody drives Lamborghinis over there, so it gets very loud. Also, this is a UV project, natural UV botanical garden inside the airport. And last example, I'm almost finished, guys. Okay, so here, this is the Apple Store. I think it's in New York. Previously, it was done with 90 glass panels, PVP and Centriglass, but I think the consultant EOC, they relied fully in the next design on Centriglass, and it was changed from 90 to 15 glass panels. That is it from my side. Thank you for your attention.
After this speaker, we'll be breaking for a networking break again. But I would like to call upon Mr. Rakesh Murudkar. Please come on the stage. Please give him a round of applause from India.
Good afternoon, everyone. I am Rakesh Murudkar, facade consultant from India, and working pan-India as well as working for international projects. So today I will be taking a subject on pre-construction of stage design, a practical approach basically. So in that, RCC slab casting for supporting the facade system, column and beams For standardizing the RCC according to the facade design loads for the facade elements like atrium, skylights, canopies, and terrace pergolas. Then RCC upstands for the facade element like frameless glass railings, and terrace RCC parapet and slab for the facade cleaning system and the BMU systems. So as today I had heard a lot of presentation where everyone was interested to showing that how the cost can be get controlled. So this is one of the part where I am going to highlight how the things can be designed in the pre-stage condition overall during the architectural engineering and engineering process in the beginning stage itself. This ensures not only the aesthetic point of view, but structural integrity and requirement for functional needs basically. By starting the facade designing, early on adjustment of the can be more sensible, seamless, and potential conflicts can be addressed, and they can become before they become a problematic basically. So it is a true study of RCC condition should be there before we start with the whenever we start doing the facade design. Use of casting channel, insert plates. In case of MS structure, it is better we can do it on the in the factory, and then it can be taken and do as a bolting system so that no weldings on the sites basically. The conclusion for this is that project cost control is there, execution methodology and sequencings of the facade can be freeze and achieve the project targets. So these are the issues what generally, so first of all I'll highlight the issues what we are facing when we have the anchoring, when we do the anchoring. So you can see the alignment of the anchors are in a very different level when the actual fabricator or labor who is working on the project. So this cannot be controlled basically. So, and also checking of this n number of anchors, it will be difficult. Next is our practical issues when we have post-tension slabs. So this is the issue. If we don't take the design in the design point of view, so after the construction is done, so these are the variations in the bracket which will be facing because of the tendon lines are fouling at the bracket locations. So this is the variation in the bracket. So the solutions for this is the casting channel. So this is the typical condition where we can, in the conventional slab, the casting channel is placed. So the first we do the grid modulation as per the architect intent, as per the aesthetics, as per the glass wastage, as per the internal layout of the architect. According to that, the grid is approved with the architect, and then the casting channels, the design what we give in the pre-construction stage, the design of the total load of the facade, what will be coming on the RCC. So this is how the casting channel product is selected. It is tied to the rebars, and then the pouring of the concrete is done. So after drying of the concrete, this is how the sponge is removed. There is a protection of the sponge in the cavity of the casting channel so that no derbies or the cement can be collected in that. So once that is done, the T-bolt is with the casting channel which comes with the casting product which comes with the casting channel. We fix up the bracket at the site, and this is the procedure what we follow. Next, this is a post-tension slab where we, as I mentioned that the grid modulation, we design it, then we superimpose the tendon lines, and wherever the tendon lines which is getting fouled, we highlight that to the RCC consultant as well as the tendon line designers, so that this can be shifted during the construction stage. So this is what we give the service, and later date all the brackets can be typical condition, so there where we can save the cost in the brackets. So this is a typical site of our site only. You can see the casting channel placed in the post tension slab. So This is a post tension, and this is a casting channel. In between the grid, the post tension slab has been placed. Then our engineers goes and verifies the dimension, whether it is as per the design what we have given. So each and every slab is checked, and then the pouring, for the slab pouring, we give the okay to go ahead the construction. Then nowadays the buildings are being designed in a structural, all are PEB structures kind of thing. So there are decking slab. In that also we have to do the reinforcement. Then in that also we have to put the casting channels. So that, in that the casting, there are different type of casting channels for this particular conditions. Basically. So this is a typical detail where you can see. This is what is the advantage of the casting channel. So we have a XY direction movement in the tolerance point of view, and in the bracket which is holding the system, we have vertical tolerances. So this makes ease of construction during the execution time, basically. So this is the difference between the SS316 and the cold roll casting channel. So first of all, the edge distance, which is we are main which we have a problem when we are designing with the anchors basically, and when it is pre-designed during the slab casting itself. Then certification, the anchor doesn't have the green building certification, but for this we can have the green building certification in casting channels. Man-hour spent, it is huge man-hour spent on the anchoring, whereas in casting channel it is less. Flexibility is, we don't have any flexibility in the anchor and high flexibility in the casting channels. Safety, like heating the rebar, PT tendon lines get damaged. In that case, as it is designed earlier, it doesn't have any problem. Ease of installation, here we need electricity, there we don't have any required any electricity for that. So we have savings, that is savings on the brackets, definitely where we are using the casting channels. So next is our MS structure, wherever we have a MS structure canopies with the loads which will be coming on the beam areas. So this is a design what we give, and according to whatever the design is given, the RCC is constructed according to that. So these are the design points, kilonewton loads which we give on the RCC, and the note what we write that the RCC consultant has to take 1.5 times or 2.5 times whatever the loads, and according to that the RCC has to be designed. Same like this is the atrium of 21 meters, we pre-designed this, and in this we had designed insert plates. So these are the loads again given for the particular locations wherever the main supports are getting held up. So this is how the insert plate designs are given. Then there is a condition where we have a glass railing, frameless glass railing. So these are the most conditions where we need to, whenever we designing a glass railing, so this 100 mm or 15 mm will not work, because here again we have to go for a chemical anchor, and that chemical anchor will be going into the mother slab, and this again increase over the cost. So better when we design anything, it should be at least 150 by 200 mm. Then for the cleaning system, so these are the cleaning system, parapet mounted. Again you can see here on the parapet, whenever the building is getting designed, this loads has to be given, so that parapet is being designed according to the loads of the cleaning system, whatever it is proposed, whether it is a parapet mounted or a floor mounted. Then like MS structure, as on the vertical condition, it is a very bad building which is been carried out, which cannot be controlled. So better to have a MS structure in a frame kind of thing, and the bolting systems can be adapted like this. This is one example. I am giving one case study of our project AIGP IT Park in Kharadi, Pune, India. So client was for Capital Land, and architect was DSP Design Associate from Pune. So this is the element. So main thing in this project was, this was at the fin elements which were designed at the southwest area location for the shading point of view. So this magenta color, what you see, it's a fin thickness of 20 mm by 500 mm, which was jutting out from the glass line, basically. So this was the detailing what we had done. So you can see the location where the openable is there, so we have to take care the fin detailing, whether at this location the fin, the openable should open easily. So that point of view, the fin design was been done. So this you can see here in the plan, the detail, this is the tender drawings where we had done the concepts. So you can see this detail. We had kept the gap of 26 so that openable was easily, can be opened in this way. And the bolt which was designed, it was a countersunk bolt matching to the fin thickness. This is a seal detail. Then there are some complicated locations where we identify the panel during the tender stage itself, so that when the fabricator is on the board, he can easily measure it, and as per the site survey, he can fabricate the panel. So this was the fin detail. So as I mentioned, the fin thickness was 20 mm by 500 mm. So we extruded this section in China, and you can see this two pieces. Again, this top and bottom piece was cut from a diagonal cut, so that wastage point of view was also been considered. So this was the assembly. So green bracket, what you see, it is again an aluminum bracket which is jutting out from the system, hold it at the first barrier location itself. So this is again an aluminum extruded bracket, and this fin thickness, this thickness was around 8 mm, and this fin was 20 mm. So it was inserted in when the fin was been fabricated and bolted to this brackets. And again, just I want to, this gap was 25 mm which we kept from the glass line to the fin edge, basically, so that the lateral movement can be taken place. So this was the actual fin. So you can see this fin was separate because here we had a stack joint. So we had created a expansion joint here, and this L was different. So when you see the design, it is in a L shape. So this was the final shop drawings which we had approved done by the fabricator. And the actual fin which we had made, we done the mock-up in China and checked it whether it is properly done or not. And this is the actual fin which was been fixed on the. So you can see the brackets which are jutting out. It is you cannot see any brackets in the fin or bolting and anything. You can see just a gap of 25 mm. Then we had done a facade testing for this in India as per ASTM and AMA standards. So these were the standards which we had followed for that. So here you can see the positive pressure, negative pressure of the glass and system which we had checked there. So this is a static where testing at the corner location we had done the testing with the fin element. Again, in the fin also pull-push test was been done so that if we need to increase the bracket, that was been also checked for the lateral movement. This was the final test which we have successfully done. And this is the actual photograph of the project. So as we are design, so a renowned facade consultant specialized in facade treatment, we are giving developers, owners, architect, PMC, corporate clients, government firms and infrastructure. Then we have in-house consultancy engineering, and then BM services, complex facade we design, facade audits, peer reviews, retrofitting in the design, facade lighting and BMU consultancy. This was our first project in 2009. We had done in Queensland, Australia. So the engineering what we had, we didn't have to go there or they didn't have to come here. So everything was done, coordinated on the mail only. And this successfully, this project was been done by. So there my partner was glass metal PTY in Australia actually. Then we had done some project in Qatar when the FIFA football was being taken place. Then some projects in Jumeirah Hills for some villas basically. This we had done in Sri Lanka. Then in Nairobi we had done, given the service to CMAC consultant as a facade consultancy for this project. 316 Upper Hills. Also, we had given a consultancy to Nairobi 88 for the windows, and there was a special structure on the terrace floor of the glass, basically. These are some projects in India. So, in this what you see, this is not a glass. This is completely a dry stone cladding on an aluminum system. And this is the glass in unitized system. Here we had used Schuko system here. Here also we had used Schuko system. This is in Pune. This is again what intent is given by the architect, we definitely follow that. So this is the actual building with the fin element of 450 by 150 mm depth. This is again what you see, a complete dead wall, it is a stone cladding. This is some building developed for the BSE, that is Bombay Stock Exchange in Gift City, Ahmedabad. This is a building, completely green vegetation on the facade. So here we had designed a MS structure. On the MS structure, we had considered the load of till the soil, wet soil, and the trees, everything. And it was covered with the metallic mesh, expanded mesh, aluminum in copper color. And whatever you see, we had created a gap for a drainage system where all the water is getting connected and through the column it is coming down. And it is maintained, we had given a cleaning system for this to maintain this complete greenery. This is just a clubhouse and entertainment building for 100 people. They have come together and made this project. This is in Surat. This is a high-rise residential building, completely cladded, glazing, and window system we had done for Panchashil Group in Pune. And this was the first Trump Tower project in India, what we had done as a residential building, completely covered with glass. Thank you for it.
Thank you, Mr. Rakesh. Okay, while the rest resume for a networking stroke coffee break, welcome back from the afternoon networking tea break stroke coffee break. I'd like to call upon Bhavraj Singh from IPDC. Thanks. Please give him a round of applause, the ones who are here at least.
Good afternoon, everyone. My name is Gurpreet Singh Baraj, and I'm from IPDC Kenya. It means Innovative Planning and Design Consultants. I'll be talking about facades, the language of architecture through building skins. What is a facade? A facade is the face of a building. It's the first point of contact when we look at a building or a structure. Beyond its aesthetics, it provides us more with its identity, its culture, and its functionality. Every facade has a story to tell us, depending on its time, place, and purpose, wherever it was. The role of a facade, it creates a visual character of a building, depending on its function and symbolism. It can be expressed at the same time through forms, shapes, rhythm, or materials at the same time. Facades through history. So according to our history, we have ancient facades which used to have heavy, huge stones with the minimal openings. And then the purpose of this was more of strength and keeping permanency, creating permanency in the environment. We moved forward to Gothic facades. Gothic facades had more of pointed arches, stained glass, and spires. Its purpose mostly was to have a spiritual storytelling through light and detail. And then there is Renaissance. They moved more into having their facades to be more proportionate, to be geometric, and be more systematic. Their purpose more was humanity, to bring balance and order into the way the facade looks, and reviving all classic ideas, so you could say it's matching as we're moving forward. Then we have modernism. Modernism is where now you could say materials started evolving. We have more of glass, concrete, and steel materials that have evolved more. And their main purpose of this was to create a simpler facade, much more simpler, to give much more functionality and transparency of what the building looks like. We move to contemporary. As you can see, contemporary speaks for itself. It's quite a bold statement. It's experimental. You can experiment what you're doing. And it has more of high-tech technologies in it, maybe LED lightings or LED display screens and whatnot. The purpose of this was identity, to give you a new identity. This is what we are in a modern field. More of innovation and adaptation to the technologies we are having with our new sustainable architecture and environment. Sorry about that. If I move forward, storytelling through culture. So facades are minor, local, identical, and traditional. They give you that image of where the place is, what is it explaining to you, if it's a church, or if it's a mall, if it's even let's say, the governor's house. They all give you a representation of dominance, of symbolism. Like you can see in Islamic facades, we have more of privacy and climatic response. They are more privately to the surrounding and everything. And yeah, if you go to Japanese are more light, simpler. They give more symbolism to explain how their buildings are, what they're building are, the traditional buildings. So they explain more with some symbolism and all. If I go ahead to this Kingala Convention Center is a perfect example of how storytelling through culture is. As you can see, its dome and its woven facade refers to the African baskets, of Asian African baskets, which represent more of peace and togetherness. This is a perfect design of merging cultural heritage with the modern technology and sustainability. So this project is basically a symbol of Rwanda's progress and resilience in for a modern identity. Facades can even give us symbolism and power. Facades communicate more of authority and value. For example, if we have government buildings, they are more sustainable, sustainability and order, because they give you more of dominance. They show you what the government can do. They're the leading people. So their buildings are more stability, and they provide more stability and order. If you see corporate facades, they have more innovation, transparency, and branding. So all the corporate facades there, we have the allowance to play around with them, what we can do, probably tell the story of what corporate firm it is or whatever it is. If we move forward to modern storytelling with technology, technology nowadays has been it's been moved quite fast, and everyone is adapting to it. So nowadays our facades do act like smart living systems. If you see, we have LED digital media facades, which are more of LED screens that give you more information and art about maybe your surrounding, or even not your surrounding, further away from your surrounding. So it's a good way of having facades. There's another responsive facades. Responsive facades nowadays have been very good with sustainable architecture, because they adjust themselves with sunlight and temperature for the building to be cooler and warmer accordingly to the temperatures. And green facade tell us stories of sustainability and resilience. It's like a proper example of turning over concrete jungles with nature, to just merge them with nature and have that nature centralized feeling to our concrete jungles. This is one of our projects we have done, Parkin. I'm sure everyone has seen it. It's in Westlands. So it's quite a contemporary modern design we have. We had its concept more to an iPad. So if you see its front, it has a big opening, which we look into it, look like an iPad to be more modern and giving its own statement as it's there on the road. Our next project is The Address. I'm sure everyone has seen that as well, because it's on the same line. The Address is a blend of elegant contemporary architecture with natural light, greenery, lifestyle, and focused amenities. We have another project of ours that's called Delta Chambers. I'm sure everyone knows about that as well. This project is a very good project for an example of what we say modern architecture and classic architecture merge. If you see, we have a very nice classic architecture facades where we have smaller windows, we have barns running around, and we have modern architecture where we're having bigger windows, bigger openings, and materials that enhance the building to look more modern. This is another project we have, 1 Canton Square. This is in Kisumu. Well, it's a very nice project in Kisumu. If you see, it's contemporary. It's a modern project. We actually introduced more of LED screens into this project. If you see that black strip going, so the new facades, as I was talking about, digital facades. So this building is a trademark building in Kisumu because it's a landmark. You can tell anyone to come at this point and nobody would miss this building out. It's creating the architecture of Kisumu to be more modern and to be more futuristic to what we would like to see ahead in future. This is another project of ours. It's called Europa Towers. As you can see, it explains itself. The design explains the brand itself. It gives you the shape of the brand E. It's more modern. It's giving you more modern feels for the facades with the openings and the bigger openings. So this concept, the client wanted us to be like, I want to see my company saying Europa from a mile away. So we had the best option to just have it into the shape of how the brand is talking to itself. There's another project we have, Verona. Verona, I'm sure everyone has heard about. There's a lot of branding going on for Verona. So Verona is a blend of elegant contemporary architecture with nature. So we wanted to not just create a concrete jungle, we wanted to create the area it is. It's in Mutangari Drive, obviously. And we wanted to create its atmosphere to be more greenery, that we stay more in you can see more of nature than just seeing buildings rising everywhere and giving you the comfort of nature more. This is another tower building we have. You must have seen Haveli Towers. It's located in Parklands. This project it explains for itself, basically. Haveli, if everyone knows, Haveli is called a castle or a palace in the Indian language. So back in the days in Rajasthan, it was there were more palaces and more, Havelis. Let me say Haveli. If I start saying palaces, I'll get confused. Let me say Haveli. So there were more Havelis in Rajasthan most of the time. So it is inspired by that. You can say it's another good example of classic architecture with modern architecture. We have good classic architecture can be explained with these big arches, with these openings and the domes we have there. And then we enhanced it with our modern materials and our modern features to it so that we can have more of a modern feel to it as much as it's a classic design. The designer's role. We as architects are storytellers in space and nature. Every detail, every texture, every proportion, every shape tells us a story. Every line tells us a story. It's not just put there for the sake of putting there. It's put there for a reason why it's there. So we need to be more considerate to knowing why we're using the shapes and how we're using the shapes to know each and every, how to create the building into the form we want to create it in without it giving an effect that it's a downfall because there's something not working there. So everything needs to be thought over. Everything needs to be looked into properly. So our responsibility in this is where we create. We are meant to craft facades. We create and craft facades that talk about the past, they live in the present, and talk into the future. So we need to have buildings that talk all these three parts of our life cycle. Tomorrow I might not be around, but if my building is around, it's spoken to me 20 years down the line, 10 years down the line. It has to speak to you like that. So this gives us a question to ask, what stories are our buildings telling us? Buildings are not just blocks standing up. You can't just put up blocks and just make sure they're blocks. We need to know what they're telling us. How can we make facades more expressive and contextual relevant? So these are the questions we need to ask us after knowing all this, then how much more importance we need to give into thinking how we need to design our buildings and our facades. Thank you so much.
Thank you. Thank you, Kavraj. That was
Thank you.
Interesting. Okay, we are heading towards the panel discussion, and that's the, I think, the last session. Okay. While they're setting up the chairs, I'd like to call upon the moderator of the panel discussion, Mr. Marco from Avanti Architecture. Please give him a round of applause.
Hello, everybody. I've been told this is the last session, so hopefully it is the last session. My name is Marco. I'm founder and director of Avanti Architecture Limited. I am going to first give yourself a silent applause. Congratulations for sticking around to the last session. And we had a lot of people talking about technical stuff today. Hopefully your stomachs are also full. So we'll try to make this a little bit more conversational, like friends around the table in a bar. Unfortunately, there is no whiskey here today, but we'll think of that. So I have a great privilege to have 4 really good colleagues that have agreed to be here today. So let me call them. We have David Kamau from Design Partnership. You can applaud as I say the names. Kushal Ragwani from Lakshman Bai Construction, Andrew Gremley, Director of Pharos, and Stuart Thier, Associate Director of Turner & Townsend. You can carry on the applause as they come here. Don't be shy. All right. Thanks, everybody. So we are going to talk, obviously, about facade, but I'd like this to be a little bit more conversational, as I mentioned. And I'd like to start with Andrew, if you don't mind, put it on the spot. The question is really more about the approach and your experience in dealing perhaps with retrofitting existing building where the facade was done but not appropriately to the kind of building, to the kind of location. And also perhaps what lesson you learned there that you applied perhaps in one of your buildings later on. So please.
Thanks. A good example is we were given the fit out of the World Bank building, which was the Delta Tower on Upper Hill. And that was a building that was a glass facade facing north, south, and east and west. As we know, what Garmick explained very clearly, it's pretty straightforward here. Glass facades going east and west can be very difficult. And one of the things we found out is that we could not retrofit the facade that was already a unitized facade. We couldn't do anything with it. We couldn't do any sun shading. The only thing we could do was add tint. And I think one of the big mistakes a lot of people make is there's a limit to how much glass tinting can actually mitigate against the solar heat gain. It does, but there's a limit. So a lot of people think it can solve all their problems, but it can't. So we did apply tint to a certain level. And then we also had a very expensive cooling system. And I believe the client has a very expensive operating cost for that building because that was a real problem. And I do want to point out that there is a difference between open offices with east-west facing facades and closed offices. Closed offices is much worse. So you can get small offices which build up a lot of heat unless you've got a properly designed facade that properly screens out the sun from direct contact. And I want to contrast this with when we were given the AAR building. That was it was a EDGE certification. So we had to do energy modeling. The energy modeling allowed us to strategically place the screens so that we maximize the amount of daylight coming in, but at the same time, we mitigate against some of the direct solar heat gain because we were in that position where the facade mainly faced west, directly towards Karura Forest, and we were able to take advantage of that view, but we did have to take some of those measures. And they had a certain cost, but it was that balance between cost and being able to protect the facade from that direct sun.
Thank you, Andrew. And I want to take what you just said in relation to, design orientation and not appreciating the sun exposure, especially east and west, had a most likely impact on the AC bill of the client. And maybe this can, Stuart, I want to move to you. In terms of costing, life cycle cost of facade, and anything to do with this duality of a properly designed facade that takes care of this orientation can also minimize the cost of running a building, which one would perhaps is not always obvious when you start designing something. Yeah, please.
Oh man, yeah, I think generally in construction and facades as well, is we often look at the sort of time, cost, quality triangle and what takes importance here and there. Now, obviously from an architectural point, people look at quality, and people from a project management point probably look at time. And then obviously quantity surveyors and the like will look at cost. Now, depending on obviously who you're talking to, it depends on what takes priority there. I think when we talk about quality, we tend to talk about that is what we want it to be. Time, we obviously talk usually about trying to be as quick as we possibly can. And cost, we tend to talk about, well, how can we do it for the cheapest possible way? But I think sometimes when you look at a facade in particular, it can amount to 15 or 20% of your overall construction value. And I think sometimes you maybe need to frame it as opposed to it being the cost, it maybe needs to be framed as the value. So you look at something and go, yes, it's going to cost me upfront a lot more, but over the period of your construction project, or the duration of the building, should we say, it's actually going to cost me a lot less, because you're taking into account additional factors, you're taking into account residual value, you're taking into account your maintenance, you're taking into account repair, you're taking into account operations. And I think when someone looks at a building as a whole and goes, right, well, how much is it going to cost in the first instance, I think try and reframe that slightly and say, right, this is how much it's going to cost, but actually it's a flagship part of your building. As you go forward in 20, 30, 40 years' time, people still potentially talk about that facade, and you don't want to cost double the amount because you've had to go and do the repair, you've had to go and do a significant amount of maintenance. And actually the running cost of your actual overall building is 3 times what it would have cost if you'd gone for something else in the first instance.
Thank you for that. And obviously the design is one thing, and the other thing is, of course, the more technical nitty-gritty, the detailing, and how the facade and the frame of the building comes together. And David, maybe you can tell us a little bit more about the things that you as an architect consider when designing a facade and how it interacts. Also the challenges that you're having on site. A design is thought out, then site condition requires the design to modify it a little bit. Tell us a little bit more on that aspect of the facade and the design and the construction.
Hello. Yes. Yeah, so I think generally when looking at facades, I think people focus mostly on there's the emphasis that is there on the design part, but there's also what actually happens on site during installation, and actually making sure that the design that has been done is what is implemented on site. So you find design can be done to spec, design can be done 100% to what is recommended from us. But now when it comes to site and the implementation, you find you might get a lot of issues with things like inconsistency in maybe how the openings are created. If the main contractor hasn't aligned the openings and things like the plaster, might also affect maybe the glazing system that you're putting there. And one of the things that you have to take into account is that you have to make sure everything that is done on site, especially during implementation, matches what has been designed, just to make sure there is no inconsistency and to make sure the implementation is done to spec.
Thank you, David. I think same question, we're talking now to site. So I'd like to move to you, Kushal, and perhaps from your experience as a contractor, maybe you can tell us your perspective on the challenges that you see, you faced, and perhaps also some examples on how you've solved most critical problems.
So I think the main issue that we see is, the fundamental issue that we see usually with facades especially, is that not enough time is given, not even thought process is given behind it. Again, I don't know, it's either driven by the developers or by the design team or by the structure, and getting on sites becomes a priority rather than actually getting the design right, getting the design coordinated is a big issue that we see. Ideally, what the approach should be that more time should be spent during the design stages to avoid things like the interactions that David talked about. A big issue that we see is where the facade meets the rest of the masonry or the works that we've done. No one has really given a thought of how that interaction will occur, what the detailing will be around that interaction. And it's usually left it, let's say, on the fabricator that has to figure that out, or it's a decision taken on site, and usually 9 times out of 10 we feel a compromise decision is taken in terms of what that interaction should look like. If there was more time, if there more thought was given to that process, it could come out even much better. And that's the reason why I think we even see, and we've experienced this, I'm not sure about other contractors, that we do have issues with leakages, we do have issues with wind penetration with certain facades. And again, it's not entirely to do with the systems or the fabricator. There's a responsibility on our side and responsibility on the designer's side as well. More recently, what we've experienced is sort of pre-installation workshops, so whereby all the stakeholders, right from the design team, from the client who's going to eventually take over the building and maintain the building, we sit down as a team, workshop through all these details, how this interaction, how this corner joint will work, or just simply which direction the door will open, will it be functional for the use of that particular space. And that's helped iron out a lot of these issues. But again, it comes back to having that luxury of time to be able to spend time on that. And more we notice the clients are becoming aggressive with their timelines. They want let's say a 24-month project in 18 months, an 18-month project in 12 months. And unfortunately, it's slightly the wrong direction, but it is what it is. And clients really need to sort of benchmark other projects that they see where such decisions have been taken without the time being spent in terms of forecasting. I think Andrew mentioned the World Bank building, where I don't know what the issue was, but potentially that could have been avoided if more thought was given to the design process itself.
Thank you, Kushal. You mentioned...
Sorry, Marco, can I just add to that?
Sure.
Sorry to interrupt. I think one of the important things I think you're basically saying, Kushal, as well, is that you need to spend your time up front. And obviously from a consultant's background, we don't get that time. I think what we probably need to speak to clients is that early contractor involvement, and actually getting those contractors in early will help that design phase at the beginning to then speed everything else up later on. And I don't think it's a dirty word basically to say to a client, look, we need the contractors to come and help everybody else, because they're the ones that are actually going to be implementing this on site at a point in time.
Yeah, perfectly agree with that. And even to a certain degree, the roles of, especially for certain buildings, obviously our market is not so mature, but having facade consultants for certain complicated projects also makes sense. Okay, obviously there is the cost side of things involved in that, but if you look at comparatively or relatively, that fee or whatever that is, it's worth it. It will work out, but it's again the convincing game, talking to the clients, again benchmarking against other similar projects abroad would help convince the clients. But it's something that needs to be thought about.
Andrew?
Yeah, I want to add to that a little bit, saying that sometimes the facade is actually being fabricated before the site measurements are being taken. So we had an issue at AR Hospital where the concrete was poured, and should have gone back and remeasured everything more carefully and tried to make those adjustments, which he did eventually, but it came up a little bit late. I'm sure Luxembourg would have done a much better job. But the accuracy, so I think what it is that the architects and the foremen need to get up on the scaffolding and actually do site measurements. And even if it's been ordered, it's best early warning system saying that, okay, we've got a problem here with this facade and the way it's being attached. We need to start making some adjustments. So I think that would probably at least adjust any sort of late changes that have to be done, like after the facades arrived. So site measurements are a critical item.
And if I was to rephrase what I've heard, which is really a matter of there is no time during the design phase where you would not just expect to design something beautiful for the requirements, for the brief, but also the critical aspect of coordination between different consultants and to develop the design that by the time it gets to site, a lot of the details and how things meet should have been thought out. If I got you right, Andrew, you're saying that basically all that coordination happens once the frame is up. So it feels almost like that anything quality control and quality assurance that Stuart is mentioning, it's happening as the construction is happening, which of course creates, in the case of the building you mentioned, inevitable rework, abortive, or redoing to fit something that perhaps is too costly to change, like a facade that has been designed. And I wonder if being aware of the market that we are working and knowing that these perhaps increased perception that clients want things faster and faster more than perhaps cheaper per se. Is there, as professional in different disciplines, change the way we develop designs or change the way or adopt certain strategies to target and to tackle these issues that we already know exist? So I wonder if maybe, David, you have some thoughts on that.
Yeah, so I think maybe one of the ways to mitigate that is I would think maybe during design, we can always make sure we factor in things like tolerances, because you know what will happen on site. So maybe give a tolerance, or maybe if it's a window fit, allow for tolerance maybe 5-10 mm, just to make sure it can be adjusted on site. Maybe that's one of the approaches we can take. Then our approach would be to, as Stuart has suggested, get the contractor on board as early as possible, so that they are part of the design, not just an afterthought, or not when you're now coming to procurement is when you now call them, just tell them, okay, this is what you're doing. But if you can involve them from the design stage, I think that's something which might help. I know there's some challenges with that, particularly for some projects which are quite strict on procurement. They might say you involving the contractor a bit early might be giving them a bit more, I would say, of an edge over the competition. So some projects are quite strict on procurement, but if you can be able to get the contractor on board as early as design, so that you can discuss all those issues, all the tolerances, what is required during the fitting stage, I think that is something that can also help as well.
I'd like to explore this a little bit more from Stuart, from your quantity surveying, preparing a BQ. How would engaging with the contractor earlier on could benefit both in terms of time and more cost accuracy?
I think in a number of ways. I think obviously when we're pricing something up, we will base it on what we believe something is at that point in time. Now, contractors tend to be a lot closer to the market than we are, and ones with the contacts, whether that's, and we might forget about, or maybe not have the knowledge, should I say, around where particular materials are coming from. Is there issues at the moment we're trying to get things into the local market? What other factors haven't we included into our upfront cost? And actually, the contractors can turn around and say, yeah, right, but that's going to cost you whatever now. But by the way, you do realise later on in time you're going to have to replace that 5 years later. So actually, can you have a look at potentially using this other material or other supplier or wherever it is that will then just adjust what we're doing in terms of the BOQ, and we can turn around to the client and say, look, you probably had a budget of this, but actually your budget needs to be this. And I think sometimes it's almost trying to flip it round, I think, and try and speak to clients in particular. And, you know, on a regular basis, we cost a design, and we turn around and go, that's how much it's going to cost. But actually, sometimes what you want to be able to try and do is, if we can get contractors in as well, is you can design to a budget and you can flip it the other way around. So if we've got the contractors in and we can say, look, we know at the moment indicatively it's going to cost you this per square meter or whatever, or this material cost you this, we can then work with the rest of the design team and say, look, actually, we need to tweak the design slightly because it's going to cost you a lot more, as opposed to everyone just going, right, here's the design, now we cost it, now we're in a mess, now we need to VE, now we need to do this. So just, I think sometimes just trying to flip the conversation between ourselves and clients in
Almost
particular.
feels like that by the time we are having those conversations, the building is already up. And somehow we are unable to convince clients to do the work that needs to be done before we actually hit the site. And I wish there was a developer on this panel. I don't know if someone is here that would be willing to join us, but it would be interesting to hear the thinking from the client side. But perhaps, Charles, you have some thoughts on that?
Yeah, just a sort of quick short point on that, and what David mentioned and what Stuart mentioned. Sometimes, in fact, it might even work to the benefit of the developer, whereby there might be some overspecking that has been done, whereas a specialist, let's say system supplier or a glass supplier, can come and engage and get, wait a minute, I think we don't need to go sort of this all out. This is something we can do. We can play around with the systems. We can maybe play around with the configuration of the glass and then get better value. So it's not just that getting involved a contractor early on gives them an advantage in terms of sort of future pricing or future chances of getting on the job. But at the same time, it will benefit the developers on the other end as well.
Andrew, you would like to add something on that?
Yeah, I think starting on the design process, if I was a developer, I would turn to the contractor and say, has the architect given you proper details? Or the curtain wall supplier, the fabricator, right? Have they given you, because you guys are too afraid to insult us, right? So I think
we want more jobs then.
Yeah, well, but I think it's fair, because if the architect hasn't given proper details, we're off to a bad start, okay? So let's assume that the details are there. Now, I think it has to be on the agenda. It has to be on the agenda for the entire interface schedule, the procurement schedule and everything. And on that agenda is, like I said, shop drawings, verification of dimensions. Is the contractor happy with it? Is the window supplier happy with it? Is the glass been decided? If those items, it's a project management thing. If those items are on the agenda for that item, and you continually go back to it. But if you're treating, a curtain wall like paint, you're not taking it seriously. It's quite a serious issue. Flashing details, all these things are extremely important. So let's make sure that the project management, be it done by the architect or a project manager, is actually taking it seriously and following up and saying, have you received the shop drawings? Have you checked them?
Having, a number of years in this panel worked here, if there was maybe a couple of things that you would encourage everybody sort of to follow as part of educating everybody and getting feedback, at least in such a way that the right questions can be asked at the right time. What could those be? Maybe, David, we start here and then we'll go around.
Yeah, I think from my perspective, I think the local suppliers and even the contractors, they're currently on the right track. Maybe one of the things they're doing that is quite good is they engage us as consultants, and they let us know what is the latest maybe development, what are the latest new profiles that they're using for aluminium, new specs. So some of them even organize seminars, maybe they come to offices, we have a discussion, we understand the product a bit better. So by doing that, it's like they've jumped now the process. Instead of now having to rely on us giving the spec first and then it becomes a ripple effect, it's easier when we already have information from them, so it becomes easier to specify, and it sort of smoothen that, that whole collaborative process to the point where now we're going to construction. So one thing that I think is being done that is good is those workshops and those seminars that involve not only even us consultants, but clients as well, and even other stakeholders in the industry. So I think that's something which needs to be commended and to keep going on. Yeah.
Jump to the other end, Stuart.
I think listen and learn. I've had the fortune of working in the UK and Middle East before I was out here, and obviously those markets are a lot more mature than here. And I don't think there's any issues someone turning around and say, look, we don't know, we haven't got the experience yet. And I think, you know, the sort of general feeling that we've got from this panel at the moment is take your time up front, get it right, because otherwise it's going to cost you a hell of a lot more money at the end. Your quality is going to be down and your program's going to be longer. So speak to people that know what they're doing, how they've had experiences, whether that be good experience, bad experiences, and learn. And I think obviously a lot of the players that are coming into the market are international developers. And I think sometimes you can probably turn around and say, look, what about your previous experiences in this region or this region? And what went right there? What went wrong there? What weren't you happy with either the contractor or your consultant team in the first instances? And what went wrong? Did you have a lessons learned workshop with those at the end of your project there that you could now bring in and educate the rest of us, you know, on this panel and people in this room that we can take forward? You know, that the market's hot at the moment and we're only going to get more and more things being developed, but we need it to be right. Otherwise, everything's going to crash and it's going to get a bad reputation across the board.
Otherwise, we will have to go back to Andrew and ask him which film he used on the World Bank in Upper Hill. But Andrew, maybe some thoughts on that as we go towards concluding.
I'll confess, I mean, for years I didn't really know facades. I didn't do those types of buildings until more recent years. And to be honest, a couple of visits over to Devendra over at Prime, I learned a hell of a lot about windows and about, technically what is required, what is a quality window versus some of the rubbish that we've seen over the years from a number of suppliers. So it has, I do encourage everybody to do supplier visits. It's my pitch for Prime, to visit these guys, can be very useful. And then, again, the contractors to challenge a little bit, and clients just, have you done your homework on this? Are we getting the right thing?
And the previous presentation from the Schuko person who is there, I'm sorry, I don't remember, I didn't get your name, but we saw quite a number of spectacular curved facade, and there is but Kushal, just to conclude, would are you, of course this is more generic question, not necessarily to you, but would you feel that contractors are also open to embrace different kind of designs beyond simple straight curtain wallings, because clearly we can do them, or some people can do it.
We have to be open to it, otherwise it's one of those things, if you don't know open to it, you're going to get left behind, as simple as that. So we are open to it, but again, it depends on the specialities or the expertise that we do. We have that expertise in the market. Okay, it might look good in Dubai, it might look good in New York, but we might not have the local expertise to be able to deliver that. So that needs to be balanced, but at the same time, we don't want to be stuck in our ways. We can't just keep relying on sort of punch windows and see that as a facade. We do need to move on, but it needs to be, again, a constructive or a collaborative effort whereby designs are thought through. There's a thought process where it's not just that it's sketched out or drawn out and then you just pass it on to, let's say, Prime Aluminium here or to Schuko here and then deliver this. It's never going to be a practical solution. both in terms of time, costs, and even to a certain degree quality as well. So it's a balance to be struck again to a time, cost, quality sort of triangle. Again, that balance needs to be struck when selecting sort of your facade solutions, and step by step rather than a jump. That should be the approach. What we believe as a sort of a contractor. Again, that's what we apply apart from facades. That's what we apply to our other disciplines, maybe tiling or ceiling finishes or whatever that may be.
Thank you. I think I would like to open the floor, just maybe for 2-3 questions. Yeah. Okay. Good. I've been given the thumb up. Anybody that would like to engage on this conversation of facade processes, quality control, sharing some experiences? I see people looking up, down, left, and right. Dev, oh yes. Maybe can a mic? Yeah. The microphone is coming. Please just introduce yourself with your name.
Yeah, thank you. My name is Levius Salasia, Swastik Aluminum and Joinery.
Sorry, can you speak louder? Because we can't hear you.
Okay, you can hear me now?
Yes.
Yeah, my name is Levius Salasia, Swastik Aluminum and Joinery Limited. It's nice to be here. So I have 2 questions, perhaps to the panel. One will be about the collaborative approach in terms of design and execution. I just wanted to get your thoughts in terms of, is it time for facade contractors to also adopt design and build as a way to deal with the issues about time and cost and getting the details right, because the contractor is the one doing the execution, and probably the pros and cons to this approach. And 2 will be about the challenge about the spec in terms of designing and also costing. David had mentioned about designers just trying to interact with the suppliers, be it glass or aluminum. And sometimes as subcontractors, we have this challenge when we are filling the bills of quantities. The spec in the bills of quantities or in the drawings are ambiguous. So sometimes, like for example, issues to do with the DB rating, or to use, like, say, for example, 8.76 acoustic glass, but to achieve 50 dB rating. And you have to price for that. Then once you get the project, then it's an issue of, well, you should have followed the DB rating or the glass spec. So how are designers or consultants in costing and design dealing with this issue? Yes, thank you.
So maybe we answer that question. Maybe, David, you want to have a go at the collaboration first? Yeah,
Yeah, I think it's a good question. So regarding facade contractors, yeah, I think it's something which the industry could be open to, especially regarding the specialization part of it. So if it's something which that can be done entirely by one entity, that is from design, build, and then they're just involved in the project as part of the design team, I believe it's something which the industry can be open to. Yeah, I think that's something which we can.
Maybe Stuart, on the issue of...
I think if I understood your question right, you're obviously saying there's sometimes ambiguities between sort of what's in the BOQ and what's in the specifications. That what you said. I think, open and honest, I think just go back in the first instance and you have to say, look, this just doesn't match, or from our experience, this is this, or sometimes put the alternative proposal forward and say, look, have you thought about this, and have you thought about that instead? Sometimes you'll get the opportunity to express that at a point in time. It's probably not the easiest question to answer, so I'm not sure whether anyone more of a design background or...
Yeah, I think I might be able to. One of the problems that we have sometimes is that our clients require us to have a competitive bid. So we have to give a specification, a performance specification versus pick an actual, because if Guardian Glass knew they were the only suppliers, there's no competition in the pricing, right? So, then you can't go to Impala or whoever it is in Saint-Gobain and try and get a better price. So I think, as you're saying, is that you have to come back in the query time to do that, but if you get that. But I just want to explain that sometimes we have to give performance-based specs because of a client requirement.
Kushal, what's your experience on that?
Yeah, I think that the main issue around that, it is a procurement route that's possible, and it's an efficient route. It's being done all over the world. But again, it comes back to the issue of trust, whereby trust and competition, that if certain party knows that they're involved, it becomes a bit difficult for the client to be able to know whether he's getting the best, obviously best product plus the best price and that side of things. But again, it should be a trust exercise whereby, again, experience should be speaking for itself. So if you've got a reputable firm that's coming to you, a fabricator, a system supplier, a glass supplier, a certain level of trust needs to be built up, whereby it is just a test that you get on with it and you trust that this will be the process. Because if we keep on going back that, can you compare it with XYZ, you will never sort of be able to get a right solution. And again, time becomes another issue if you try and keep doing that. So it's an approach change, it's a sort of a mentality change, but it's something that more and more developers need to start keeping in mind as they go forward, especially on your more complex projects. Let's say your simple projects are easier to sort of compare with or benchmark with other projects. And then again, we're not sort of a mature market. So again, even if you have a doubt, if there's a trust issue, look at benchmarking internationally. Obviously, a firm like Stewart's here do have other projects that they can bring reference to that. Look, this project in the UK cost XYZ, we factor in and we present it in that manner. Maybe that could also help convince clients that no, working with a certain group of only, let's say, a single chain of delivery chain, it will be beneficial to me.
Thank you. Another question from anybody? Raise your hand, right or left. No one? Everybody's looking for the bar, for the exit, yes? I was told no bar, sorry, only coffee. We're done? All right, thanks everybody. Please, a round of applause for the panelists.
Yeah, thank you, Jay, for taking us through the program. And once again, well then, we have come to the end of the day. Thank you all for your time, support, patience for making this event another successful one. To all our sponsors, our presenting partner Shuko, our associate partners again, Prime Aluminium, Kurare, Ashton Extrusions, Gujarat Guardian. I once again thank you all for your support. Like I mentioned in the start, our next conference here we have in Casablanca, which is on 26th of November. If that market again is a region of interest to you, we are more than happy to welcome you to visit the show. The networking zone again is open. If you wish to continue networking, you are free to do so. So take care, stay safe, and looking forward to growing the industry together. Good evening all.